we would offer it again, and there's a lot of great talks lined up for you today. I just want to remind everyone to please silence your cell phones. And finally, I'd like to thank our sponsors for this event, especially our diamond sponsors, Delta Designs and Picture, and also Pest Tech, who's sponsoring this specific session. So with that, we'll get things started. I'd like to introduce our first talk, Jing-Fu Tsai, who will be presenting on scAnt 3D model platform. Thanks.
Good morning, everyone. I'm Jing-Fu Tsai, curator and collection manager of Entomological collection at the National Museum of Natural Science, which is in Taichung, central Taiwan. Today, I will talk about the exploration of our 3D scanner scAnt using the insect specimens. Okay, let's have a quick start with an overview of our museum. Established in 1986, and we are quite a young natural history museum. In addition to the main museum, we have 3 affiliates: Cheolongpu Fault Preservation Park, 921 Earthquake Museum and Education Park, and Fenghuanggu Bird and Ecology Park. The first 2 are established following a devastating earthquake in central Taiwan in 1999. We have 6 departments, and a botanical garden, 3 with 10 individuals and 19 collections: biology, geology, and anthropology. Other departments including exhibition, science, education, collection, and information. With 465 employees, including 69 researchers, we strive to promote research, education, and outreach. Now let's take a look at our entomological collections. We have 2 collection rooms covering an area of about 340 square meters, capable of storing over 50,000 drawers, which is space for up to 3 to 5 million pin specimens. These collection rooms are equipped with advanced features such as access control, facial recognition, and real-time monitor of temperature and humidity. Over the years, we have registered a significant number of specimens in our entomological collection. From 1986 to 2023, the accumulative registrations have reached nearly 1 million, with an average of 28,000 specimens registered annually. Among the insects, the most prominent ones in our collection, including beetles and ants, wasps, and cicadas, stingbugs, moths, butterflies, and flies. In the past 2 decades, we have undertaken extensive digitalization efforts, particularly focused on the type specimens described from Taiwan during the colonial period, and thus deposited outside the country. We visited about 15 museums worldwide, documented nearly 4,000 types and 2,250 species. Additionally, we catalog 4,070 types specimens of nearly 1,000 insect species from our own collection. We have developed an integrated online types database, which you can access through the provided QR code. And through our examination of specimens, we have identified 4 species that are extinct in Taiwan. 2 of these are the purple crown butterfly and the monarch butterfly, were donated from the Senckenberg Deutsche Entomology Institute in Germany. Unfortunately, these species were wiped out around the early 20th century due to habitat loss. The other 2 species have recently become extinct. We have also acquired valuable artwork, including butterfly wing collages and numerous specimens donated by the descendants of a butterfly processing company in Taiwan. The butterfly handicraft business was thriving in the country between 1950 and 1975. About 15 to 500 million specimens were exported from Taiwan annually. Total value was about $30 million. These specimens and artwork serve as a witness to history, demonstrating the decline of butterfly populations and providing important lessons for conservation. To celebrate our museum's milestones, we curated a special exhibition called Open Up the Precious in 2011. These exhibitions showcase 100 treasures from our collection to the public, represent various fields such as zoology, botany, geology, and anthropology. We published a book and made the exhibition available online. In recent years, there has been a growing trend in museums to transition from physical to digital access. This shift aims to overcome limitations in preservation and access, making collections more visible to the public and researchers. We can observe this trend evolving from 2D images with increased depth of field to more advanced 3D models. In 2021, a novel 3D scanning device called scAnt was created by the researcher from Imperial College London. This open source low-cost micro 3D scanner utilizes photogeometry to create high-resolution, full-color photo 3D models of insects in various sizes. The device includes a 360-degree photo booth, providing a controlled environment for scanning the specimens. Unlike the other 3D scanners that are unable to capture smaller objects, scAnt employs photogrammetry to achieve more resolution levels. This process involves taking a series of images from all angles of an object, and thus using software to stitch them together into a 3D model. While the soft part is rather easy, you load in the images and let it run. The hard part is to collect suitable images. So the images must be very numerous images, be equal illuminated and no shadows, and be of identical focus length, be in focus and a crispy focus background. So to demonstrate the practical application of scAnt, we have assembled our own version of the device based on the open source design. We will now show you a video that provides further explanation and showcase the scanning process. So now become the video.
Macro 3D scanning technology is capable of converting small objects into colored 3D models. By taking photos at different focal depths and stacking them, shallow depth of field photos can be turned into clear and complete images. About 40 photos need to be taken from a single perspective. With our device, assembled from the open-source scanner scAnt, the illumination dome can automatically surround the object and capture about 180 perspective images with the camera in a 360-degree photo booth. After processing with a photogrammetry software package, a 3D colored model of the object can be reconstructed. In academic research, the most useful application is a 3D database. In academic research, the most useful application is a 3D database of type specimens. Through our viewing platform, users can freely rotate the specimen model and view a high-resolution image from any corresponding angle. In educational promotion, augmented reality technology can bring specimens to everyone's home. The corrected 3D model can also be used as material for animations. The above demonstration only scratches the surface of the potential applications of 3D scanning technology. Thank you for your listening.
Us to prevent the corresponding present the corresponding 2D and 3D images simultaneously, enhance the viewer's experience. Let's check the video for a demonstration. This comes on the second video.
This is example of our museum 3D platform website. The left side displays the 3D model, while the right side shows extended depth of field images from the corresponding angle. Lower left side provides species and distribution. Lower right side displays locality and identification labels. The bottom shows the constructed insect 3D models. Let's begin with the 3D model of the jewel beetle. a beautiful species with bright metallic luster and endemic to Taiwan. Its larvae feed on the endemic conifer tree. The specimen is about 15 millimeters long. As you rotate the 3D model, you'll notice corresponding images appearing on the right side. You can zoom in and see the texture details on any area of interest. Now let's move on to another model, the tree hopper. It has a very strikingly modified thorax, which shows the antler-like horns laterally. The specimen is about 9 millimeters long. As you spin and zoom in the model, you can see details such as short hairs scattering on the body. Finally, let's check out the red assassin bug. It has a very bright in color and is about 15 millimeters long. Like the previous demo, you can see the details of the characters by rotating and zooming the model. Due to the soft limitations, the 3D photogrammetry modeling may still have flaws on some structures. However, the lack of details in the 3D model can be supplemented by 2D images from corresponding angles. This can help reduce character misjudgment. It may be more practical than spending much more time on digital editing and obtaining unrealistic results.
Due to the software limitations, however, our method of simultaneously displaying 2D and 3D images can help mitigate these problems. So there are many things to be done in the collection, but how can we efficiently accomplish with these limited resources and time? We believe that the effective utilization of 2D and 3D models relies on the power of a compelling story. Let me give you an example of the Asia papilio butterflies. By using museum specimens and reconstructing mitochondrial phylogenomics, our colleagues have discovered that the Taiwan endemic and protected species share the most common ancestor with American papilio butterflies. This indicates their dispersal to Asia through the Bering land bridge approximately 18 million ago. Another case is the it's about involving the complex, the transoceanic colonization and the speciation of Pachynrhynchus weevils, which have evolved within 1 million years between Luzon, Philippines, and Taiwan. These weevils have experienced both short and long-distance dispersal events in both northward and southward directions. So last, I would like to highlight the discovery of a new family and genus Reka and a new species of amongst lacewings, which was published last year from specimens in our museum. This species is a cicada-sized insect, but never been discovered in the last 2 centuries, until the photo was posted on the Facebook in 2017. Its discovery was attributed to the citizen science. So I would just want to emphasize the story of the specimens doesn't matter. So in conclusion, it's not enough to simply possess specimens in our collection. We must conduct the research, interpret the findings, and share the story behind them through the digital assets. By emphasizing the value of natural history, promoting open science communication, fostering public engagement, we can generate general public interest and support conservation initiatives. Lastly, we hope to establish connections with natural history collection worldwide. Thank you so much for your attention. And I'm very happy to answer any questions or after talk or email to me. Thank you.
Thank you. That was awesome.
Thank you so much.
On average, how long does the scAnt take to do the imaging for these specimens?
How does what?
How long does it usually take? Because you do so much of the stacking for the image data.
Okay, it depends on the size of specimens. For example, because we take the 180 degrees, so each angles have about 40 images to stacking up. So it's about 60,000 images to produce the 3D models. It takes 4 to 6 hours per specimen. Yeah. Thank you.
All right. Hello, everybody. My name is Luca Voß. I'm a collection technician from the Natural History Museum in Berlin, Germany. And I'm currently working in the ichthyology and also the herpetology collection. And I'm mainly tasked with digitization of the wet specimens. And throughout my 1.5 years of doing this now, I've learned that good field labels can save you time and sanity, and that's why I want to talk to you about it. First, what are field labels? Just so we're all on the same page. Field labels link the collected specimen with the data from the collection event. And the gold standard that I could find, because there's not really a lot of literature about it, that I could find is that you just take the field number, put it on a label on both sides and attach it to the specimen. And while that can be a really great way to link the specimen with the collection data, I've seen quite a few challenges with it due to either use of inadequate material or due to the data not being handed over or the digitator being lost or just wrong. And that can be a big issue because if we don't have the collector with us anymore, we cannot rectify, or oftentimes we cannot rectify these mistakes, and that leads to a loss of information, which means that the specimen just becomes less scientifically valuable, and that's why they were collected in the first place. And also, these specimens that now don't have information to them basically are also waste resources like money, space, and time. And in order to circumvent all of this, so that the collector can collect the specimens, and even if they drop dead on the spot after collecting the specimens, you can still work with them in 50 years. I'm now going to tell you about how to best achieve that. Firstly, what kind of paper do we use? So we found that as far as weight goes, a little bit thicker paper, like 90 grams thick paper, is less prone to tearing and also to dissolve in liquid. And it's also easy enough to fold over, which is going to be important later on, but not too thick that it will hold also the folded over part. And also there's less damage to very sensitive specimens like amphibians that have really thin skin. It should also be porous in our experience. Otherwise we had paper that was way more smooth, which led to the letters just coming off in a liquid, which is a great party trick, but not really what you want if you want to look at the information actually on the labels. And it should also be acid-free, so the paper is not dissolved, but also the preservation fluid is not contaminated. Then you need something to write on the paper. Honestly, for us, a lead pencil is the best, easiest, cheapest method of achieving that. Also, the collector can also write in their field notes with it. It's honestly the best way for us. ICOM, I looked up what ICOM has to say about the matter, and they said a soft lead pencil, which is sort of not really concrete measure, but we personally have found that an HB hardness, or for US a number 2 pencil, produces the best legibility. If you're opting for a more long-lasting or sturdy pencil, you could just look into getting a mechanical lead pencil and refillable with refillable graphite mines. Then the most important part, arguably, is what do we put on the labels so we can use it later on. Firstly, of course, the field number. If we have anything else that is also attached, like habitat type, we can put that in the field book. Then a first identification could be frog, could be identified, could be a species, anything that sort of tells me, is this field label belonging to that specimen. Then a full location with coordinates, a full date, and the full name of the collectors. The label actually has gotten a little bit longer because I got feedback right before coming here. So I couldn't change the presentation anymore, but it's like half a centimeter or 0.2 inches longer now, in order to ensure that the reinforcement on the right-hand side can be sufficient. And then basically, so I made a template, a label template that I also brought today. In my label template, I have on the right-hand side a dotted line where you can fold the paper over to reinforce where you're gonna punch the hole, basically. And we found that actually a hole punch that you use in leatherworks actually works really well to punch the hole. It's clean. You can also use a needle if you don't have that. That is also sufficient. And lastly, what kind of string do we use to attach the label to the object? We use a 100% linen string that should be smooth, because otherwise it is more prone to swell up in liquid. And it's also, we find it easier to handle than the more porous linen. It should be acid-free for the same reason that the paper is acid-free. And it also should be long-lasting, of course. We use sort of a 3-knot method where we make the first knot shortly after the label, the second knot a little bit like a centimeter down, and with the last knot we attach the specimen, the label to the specimen. So if there are any important identification features or traits nearby, that you can sort of scoot the label out of the way and then look at the traits. And I'm aware that, of course, attaching the label via string to the object is not always possible, but it should always be strived for, because it's the easiest way to also see the information right away. So I want to thank our head of the science program collection development and diversity, Christiane Quaiser, for giving me the opportunity to speak here today. And I also want to thank both of my wonderful supervisors, Frank Tillak and Edda Assel, respectively, for being such great supervisors. And I learned so much from them in these past 1.5 years. These are the sources. And then I also have resources. As I mentioned, I have made a Word template. I also have empty Word template sheets with me, and also prepared basically labels. If you want to look at them, if you want to take them home with you, just come and find me and talk to me. I also made a Word template where you can autofill the field numbers into, because we're all lazy and we don't want to really write that much. And I also made a tutorial on how to do that, and some other resources. Just write me an email. I will forward you the link to the Google Drive where the stuff is. And thank you so much for your attention. And this is the summary. And yeah, questions, feedback, anything, just, yeah. Thank you.
I was curious, do you always tend to write in pencil, and have you experimented with using pens for field labels?
So basically, we also have pens, but there is pens with indelete ink that we have experimented with. They sometimes need some time to dry, so it's always sort of a mix up, especially if it's raining. I don't know if that's the easiest way to write in field, which is what the field labels are for. In the museum, yes, we have experimented with that as well.
Hey, great talk. So in a lot of fish collections, you have a jar with a bunch of fish in there as a lot.
Yeah.
Do you recommend attaching a label to every individual specimen? Or, what do you do in that case?
So yes, that is an issue, having the lots. I would recommend actually attaching a label to every individual and giving every individual a number. Just if a researcher comes and works with the specimens, it's way more easy to have them just write down the number that's up on the top, and then you don't have a hassle of doing the digitization basically, or splitting up the lots afterwards, if that's possible. Of course, there's jars with like a lot of fish in them, and then you can't.
I have two quick questions. I was wondering if you have problems with the labels getting tangled. I've encountered that sometimes in jars of wet specimens.
Yes, that can be an issue, absolutely. That's why you always have to see that you basically leave the space wide enough so you can sort of take the label off, but not too long so you don't have like a big entangled mess that you're just pulling out of the jar. And then you also have to keep in mind, of course, where you're attaching the label to the specimen, because that area should at least be a little bit more sturdy.
And then I was also wondering, because you're spending all this time typing in all your collecting information into field labels, if you have a nice automated way of that becoming, linking that to registration numbers or accession numbers and.
So I know how to basically get information from an Excel sheet and auto-generating that into a Word template. That can be very helpful if you have the accession numbers basically in there already. I can send you a link. Yeah. Thank you. Thank you so much.
Good morning. My name is Margo Yousse. I'm the collections assistant at Denver Botanic Gardens. And I'm going to tell you about a little project I've been working on. But first, I have to plug this super cool piece of public art that we have out in front of our building. It's a giant metal leaf, and in each section of the leaf, it's kind of hard to tell from this photo, but there is a cutout of a herbarium specimen, its silhouette. And underneath each silhouette is the catalog number, and there's a little sign with a QR code, so anyone can go and look at our collections from this cool piece of art. So we recently moved into an amazing new facility, and if you have any questions about how we moved, I did a whole presentation on it last year. So I'm happy to talk to you about that. I planned the whole thing. So the Frere Newman Center is actually, the full name is the Center for Science, Art, and Education. So there's 3 departments in this building. We've got our art and exhibits, our education, and then our science department. So we've got galleries up on the 2nd floor, this cool immersion wall that has like different beautiful photos of cool places in Colorado. And then on the ground floor at the back of this wall, that's our natural history collections. Here's what it looks like when you walk in the front door. So And it's free for anybody to come into the first floor of the FNC. And so this is literally the first thing you see when you walk in. So the hope is that we're doing passive outreach by just existing in this space. People will walk in and like see the word herbarium on the sign and wonder like, oh, what's that? Or, oh, look at all the cool stuff that's happening in here. And so we got a grant from IMLS to move all of our stuff. We're relatively small. We just celebrated our 100,000th accession across our 3 different collection types, which I'll tell you about in a second. But we were able to buy a bunch of new cabinetry, and based off our recent collection rates, we guess that we've gained about 50 years of growth. And I just love these 2 pictures because in 2016, I was an intern and super excited when they told me I was going to be in a photo shoot. And then here I am 6 years later in a full-time permanent position. So I tell all my interns, like, there's hope for you. Thank you. Thank you. So we gained all this new space, and not only to house our collections, but also to house all of our processing supplies. And I am a person who is super into cleanliness and organization. So the new building opened in 2020, and I don't know if you remember, but this was about the same time that Marie Kondo had a show on Netflix about organizing, and also The Home Edit had a show on Netflix about home organizing. So I got really into it. So now, before, all of our like field processing supplies were in the same physical space as the herbarium processing supplies, which I'm sure this group knows like is not ideal. So now none of our field stuff mixes with our herbarium stuff, and they're actually separated by 2 closed doors and a hallway and door sweeps. So this is amazing. Huge upgrade. This is the inside of the herbarium, how I have our supplies organized. And this is our old and new field collection stuff. So I call this area in our new building the prep room, because you prep to go out into the field. So it has all of our field stuff. But then you also prep your specimens before they can come into the herbarium. So this is also where we have our dryer and our freezers, and, you know, like cactus processing, anything that's like specimen processing lives in this room, which is just amazing. We have this like really nice table to work on. There's, you know, sinks and stuff in there. So huge upgrade. And like I said, we're relatively small, but we're still actively collecting, which is great for us. Our plant collection is our main focus, with about 80,000 that's specimens like still in process. So actually cataloged, I think it's closer to 70,000. But we also have the largest collection of macrofunga of the Southern Rocky regions in the world. So notable. And then our arthropod collection is quite small, and it's also quite new. It's our newest collection. It was started because horticulturalists would just be like out in the gardens seeing cool insects and other things, mostly insects. And they thought, you guys do collections, like, don't you want these? And so after a while, we decided, like, okay, if you're going to collect them, we might as well hold on to them. But anyway, what I mean to say by all of this is that, like, we have a relatively small collection, but we've got a ton of resources. Like, these are 6 people out of our whole research department that are just focused on collections, or at least helping do collection stuff. So I mean, the resources that we have are just like unmatched. And like, this doesn't even mention that we have like 20 really dedicated, really skilled volunteers who have, you know, been there longer than I have been alive. And they absolutely know exactly what they're doing. And they provide so much use. So we're really lucky that we don't have to spend all of our staff time worrying about specimen processing. We can spend our time making protocols for how other people can process things. So that's a good segue to set myself up to talk about how important small herbaria are. We have like a weekly research meeting where we talk about a paper, and somebody brought this paper, which is awesome because my undergrad advisor, Ross McCauley, was a co-author here. And I just know from being at school with him that if you are a professor at a small university with any type of herbarium, like you are overworked and you don't have time to research best practices because you're busy training your new semester of work study students. And you know, they're cycling out every semester, and like you just, yeah, anyway, you all understand. But the point of this paper was basically just saying that like these small collections are extremely important because like relative to really larger herbaria, they get specimens through the processing process quicker and then onto biodiversity portals like Symbiota. So, which makes it the data available to researchers quicker. So these are really, really important herbaria. They're often underfunded and don't have, you know, staff resources that we have at Denver Botanic Gardens. So I decided, like, you know, well, first of all, we have this brand new building and we have to decide like, how are we going to change our workflows and like, how are we going to navigate our new spaces and like, how can we also incorporate best practices? So I just was, you know, this all started out as me rewriting protocols just to reflect like the new spaces where you can find stuff. And then after a while, I was just like working with my volunteers and we were kind of, you know, they all had to go away for COVID. And then we had to do, you know, retraining after they had been gone for like 3 years, but because we had to close before the move to prepare for that. And anyway, so I started writing a bunch of protocols and they're all super detailed. They've got screenshots and arrows and call outs and all of this. But really they are hellish to read. And nobody actually wants to spend a bunch of time going through them unless like you're brand new and you really, anyway. So then I was like, shotgun version, I'm going to make workflows for people. And this is a single page, just something to have next to your workstation or next to your computer. And it's got, you know, different colors where you need to like make a decision and then it'll tell you what to do based on the answer to the decision that you made. But I also realized that like not everybody learns the same way and not everybody can absorb information that's just written on a boring piece of paper. So I also made some instructional videos because another resource that Denver Botanic Gardens has is our own film production department, who is a guy, but he's very lovely and fun to work with. So I've got all of this great content about how we do our stuff. And so our head curator was like, this has got to be useful for somebody else. And also you just spent all this time doing all this stuff. Why don't you like put it out to the world and make it more available for people? So that's kind of what I started doing. So just to back up a little bit, well, these are my two of my wonderful volunteers, Belinda and Jan. But these are the steps that we take at the Denver Botanic Gardens to get a specimen from the field and into the filing cabinet. And I also need to caveat that I'm only doing plants right now. I'm a trained botanist, so fungi and arthropods are not my strong suit. So I'm, you know, just taking manageable bites, starting with the plants. This is what I know. So for each one of these 10 steps, I have a protocol and I have a workflow and I have a video. So hopefully anybody who wants to step in and do this stuff at the Botanic Gardens should be able to, you know what's going on. But I just have some more detailed examples here. So protocols are, like I said, many pages long. This is the shortest one, barcoding. It's 3 pages. And like I said, it's got a lot of pictures. And like we're using SignNet, which is a Symbiota portal. So it should look the same whether you're using like any other Symbiota portal. That's the whole idea, that they're the same. So in theory, it should be pretty easy for me to translate this into our mycology side because we use MycoPortal there. Anyway, this is what that looks like. I hope that it's clear, but every time I have an intern or a volunteer start on a new one, I say like, here's the protocol, please take some notes for me. So this is a work in progress. The workflows, so these are 3 different workflows because they're each one page. And the barcoding one was so simple that I decided that I'd just add some callouts on that too. And I'm still trying to decide like what colors actually make sense. Like green is good for start, and I feel like red would be good for end, but red is also so attention grabbing that I wanted red to be like, it's kind of hard to read, but it says in the middle one, the first red thing says, does the specimen have a barcode? So if you're imaging and it doesn't have a barcode, you shouldn't image it. You should put it back in the section that says to be barcoded. Things like this, just to make it like, I'm really trying to make it as easy for people to do the right thing. Like I want them to just not even have to think about, oh, should I, like use this other piece of material because it's more, even though it might be a little bit harder or it's not the easy way out, but it's the right thing to do. I just want to make the right thing to do the easiest thing to do so that people have like no questions about it. And then the videos they're fun to make, but it was tricky because I wanted my protocols to have the same look and feel as my videos. So I like wrote the protocols, filmed the videos, and then took screenshots from the videos and put them back into my protocols. So now that I've watched the videos and like found all of the things that I need to edit out or whatever, it's going to be a bit of effort to go back and change them. But if you have 20 minutes to spend and like sit down to watch this, me literally like doing a couple examples of these are mounting. So they'll be on YouTube when they are finished. So this is, like I said, just for plants. And we have a lot of resources for plants. Like we have a whole herbarium handbook, which is great. But there's not as much information about fungal specimens and mycology. But my wonderful colleague, Andy Wilson, he is a part of the North American Mycological Association's vouchering project. So last year at Telluride Mushroom Festival, he, together with Gabriella Delia, I think is her name, she's from the Fungal Diversity Survey, they made a wonderful video that is currently now on YouTube about how to collect a mycology specimen in the field. And I really appreciated your talk, Luca, because field labels are everything, especially when you are at one of these like citizen science forays where you have just a bunch of amateurs getting together and like collecting specimens that they want to be for science, but they don't know how to collect data or what that looks like. So once we get the plant stuff out of the way, then we're gonna really start going through our mushroom protocols, which is nice because, they have different seasons of intensity. And Andy also has this working group with a bunch of other North American institutions that he's working with to try and like get at best practices for fungaria. And so eventually we're thinking that maybe this could be a thing. But, that's still in the works. But if we decide that we want to make a fungarium handbook, I have an idea for our cover shot already. Lastly, I just wanted to highlight my wonderful, awesome friend, Vanessa, the nerdy naturalist. If you don't follow Denver Botanic on Instagram, you're 100% missing out on excellent content. She has agreed to help me. So we have a whole translation team at DBG, which is another wonderful resource. She has agreed to help me translate all of my workflows and protocols and videos in Spanish so that it will be useful, hopefully, for people in South America, which I know have even fewer resources than us in North America. Yeah, so I just thank you.
Thanks. Hi, my name is Tonya Haff. I'm collection manager of the Australian National Wildlife Collection, CSIRO, which is in Canberra, Australia. And we're a pretty young collection, mostly started in the early 1960s. And today I want to talk to you about bird nests. So you probably don't need it, but I just want to emphasize the importance of nests as voucher specimens, because I think they're often undercollected and underrepresented in natural history collections. But bird nests are, they're really cool. They're appreciated. People are like, oh, that's so cool. They're beautiful works of art. Or they're like examples of animal architecture. But really, nests are also incredibly rich sources of biological data. And they contain, I think, a lot of types of information that you can't get from whole animal specimens. So they're built of local material over a pretty short period of time. Young birds grow up in them. Their feathers break open in them. They poop in them. They drop food in them. Other creatures move in, insects, ectoparasites, and live in them. So really, a single nest is a habitat. It's an environmental sample. It's an indicator of breeding status. It's a record of species-specific behavior. And when you collect them over time, they're documentation of urbanization, environmental change, and climate change. So basically, if you all don't already collect nests, you should. So at the ANWC, we have collected nests over the years, but and we have received a lot from donations from private egg collectors as we've been gathering those old collections into our collections. But really, mostly we were going out and collecting whole animals, and we still do go on expeditions. And this makes people really busy. They have to deal with a thing that's going to rot. And so nests have tended to be ignored. As you can see, basically what's happened over the years, and these nests are easily from the 1960s, 1970s, collect the nest, shove it in a bag, pile it up in a box, stack it on top of each other, and forget about it because there's a lot of other things to do. And yeah, so the conditions haven't been great for them over the years. And this has led to some problems with the nests as we've more recently been going through and starting to register them and carry them properly. They've been disfigured. Most of them haven't been databased. And look, a damaged nest, a crushed nest isn't a useless nest. There's still a lot of data in there, but they're not as pretty. They're harder to subsample because you can't get to the bottom of the cup. And they're just a lot harder to work with. And I should say that we've done a lot of work in New Guinea over the years. And so these damaged nests are from species that may never have had their nests collected for science before. So they're actually incredibly important, even though they don't look great. So we started to think about what can we do as we're properly curating these nests to help them out. And we thought, well, nests can get wet. Nests are kind of designed to be wet. They're designed to be out in the elements. And so is there some part of that that we can use to help us restore them? And so we decided to create a humidification chamber and try to restore nests using humidity. So this is basically made of really common parts, really cheap and easy to get. It's just a huge Tupperware that we got from the supermarket. There's an upturned plastic lab tray at the bottom. Probably the most expensive part was a hygrometer to measure relative humidity. Got some tubing and a ultrasonic humidifier. And that's the system. Here it is in action. So basically for each nest, before we humidified it, and I should backtrack a little bit and say we decided to trial this on on about 11 nests that we had that we knew what species they were. They're from New Guinea, but we didn't have any provenance data, so we thought they were pretty safe to experiment on. And also when we happened to, yes, have the data on the nest dimensions when they were collected in the field. So we had that to go back to as a reference for kind of what the nest should look like, although we didn't have photographs. So we placed the nest on this upturned tray. That's to prevent any water that's condensing and pooling at the bottom of the Tupperware from soaking it, because we don't want it soaked or really even saturated. We just want it damp and pliable. Put the humidifier on using demineralized water, and we let it sit like that for about 10 minutes at 100% relative humidity, and then we just left the nest in there. Checked on it about every half an hour until it felt soft and pliable. And once the nest reached a point where we felt like we could work with it, we just take it out and put it on a foam board and pin it out. And for nests that were either there wasn't a lot of structure in the cup, or that were dome nests, or that we felt might need a little bit of extra support, we just dampened some archival tissue paper and put that inside the cup to help them as they dried. And we left them like this on the pinning board for 10 days to 2 weeks until they felt, we thought they should be totally dry. And then we removed the pins and we let them sit for another week before remeasuring them, and then properly putting registration tags on them and putting them away in there. Actually, that's not true. We put registration tags on before, and putting them away in archival boxes. And I just want to give a shout out for blow darts, because if you don't already use blow darts, you should. They're amazing. They're so useful. You can buy them on eBay. They're not expensive, and they're useful for such a wide variety of tasks. If you do a lot of specimen prep, or in the future when you're fixing all your old nests that you've also ignored for 50 years, they're really, really useful. And so this is just a graph to say we measured nest area of the entrance and then nest depth as well. And this is just before the original measurements, the squashed measurements, and then restored measurements. And look, it wasn't perfect, but in general, nest area is more similar to the original nest area than it was when it was squashed. And similarly for the nest depth. And this is a picture of all of the nests that we, before and after pictures of all of the nests that we humidified and restored. And I'm not trying to say that what we did was a panacea, but I think it was a good start. And one thing that I'm really curious about is kind of the memory of the nest material to hold its shape. So they were built over the course of a couple weeks. They were used over the course of maybe 3 weeks or less. And then they were crushed for 50 years. So the memory of being crushed is probably a lot stronger. And so I'm not convinced that once we had removed the pins and let the nest sit for another week, they didn't revert a bit back to their old shape. And so what I would really like to do is continue doing some experiments with humidifying nests, reshaping them, placing them still pinned back in the humidifier, rehumidifying them in that shape, and maybe trying that a few times and seeing if that helps them break that old memory of their inappropriate shape. And I just want to finish by saying that adding nests to your collection can be easy. So I know that well, perhaps one of the first things that you think is all the permitting, the ethics permits that comes with collecting nests, but I actually think that collecting nests can be way easier than collecting live vertebrates, because they're not used for that long, and once they're depredated, abandoned, or fledged, there's not any real biological reason that we couldn't be collecting them. And in fact, there's lots of research groups, nonprofit organizations, bird monitoring groups that are doing nest searching and nest monitoring as part of their protocol. And if we as local museums could get together with those groups, then we could be collecting nests, pretty much ethics free, ethics light, and collecting nests that have a whole lot of scientific data associated with them, and probably often of even rare, endangered, uncommon species that are very unlikely to ever come into our collection if we're relying on just the public being like, this whatever robin nest blew out of my tree, do you want it? So with that, I just want to say thanks to all my collaborators, and this is all published, so if you want to know more about it, check it out. Thank you.
Can I ask, how did you document the steps that you took to rehydrate the nests in the records associated with the nests? Like, did you put it in the database?
Yeah, so we'd put that in the database, but it would only go in our database, we've just been changing over our database to specify. I think there'd only be really documentation for that in a notes column, but actually I have to admit that there might be something hidden in specify that I don't know about. That would be a more appropriate place to keep that information. But for sure, we would want to document that.
Okay, thank you.
Sure.
Hi, Tonya, that was fun. I love nests and they're so underused. I had two questions. So with the humidification, I was wondering if there was any mold growth or fungal growth on the nests?
No, in fact, I think the only problems I've ever seen on any of our nests with fungal growth is when people collected them in the field and put them in plastic bags. So they weren't adequately dried before they were stored. Mm-hmm. But Canberra is a very dry climate, and just leaving things out in our prep room is adequate to completely desiccate things. And then we're not storing things in plastic anymore. So I haven't had any problems with that. I mean, just like we dry out study skins in the same environment, and we don't have any problems with mold for them.
And the second question was, because nests can be used to extract environmental DNA to figure out sort of what's in them, whatever, all kinds of questions, yeah. Right? Are you thinking, or have you actually tried to extract DNA from like pre and post humidified nests to see if there's an impact, basically if you get degradation?
No, but that's a really cool idea. I like it.
Okay.
Next paper.
Great.
But when you were asking about mold, that just made me think about the fact that Ainsley had mentioned that odd beetles were, a problem in her nest, and nests can be a problem area because they can have feathers and other organic material that is food source for museum pests. And I don't have a great solution for that because I don't think sealing them in plastic bags is perhaps the best idea unless you have moisture, like silica or something like that in a sealed bag. That might work, or else keeping them in really, elevating them to the level of whole animal specimens where you actually keep them in cabinets, where well-sealed cabinets where their pest risk is lower.
Yeah, great, thanks.
Thanks.
I did have one question, Tonya. I think we still have time. I was wondering if, I know for our nest collections, they're really historic, but I do find they have like balled up newspaper from, 1865 or whatnot. So do you think it's worth, as just maybe a collecting protocol, once the nest is fully dried, sort of trying to pad it out to maintain shape, like with maybe Tyvek and polyfill or something, modern newspaper?
I struggle with that concept, actually. And I really think that it would be, because I'm not like a conservationist, and I think I would really love to have those conversations. But I can say on a nest that I recently humidified, that's a dome nest, and it has, the reason I was humidifying it is because it had structural problems. And I did put a piece of archival, like crushed up archival tissue into the dome, because I didn't think that it was going to be able to hold its shape over time. So I don't think it's a bad idea. In my experience, like with cup nests, they seem a lot more robust, and that's their natural shape anyway. So I haven't found the need to pad them out as much. Just in the picture that you saw, it was mostly just helping them hold their shape as they were drying and while they were soft and like a bit more fragile. But the newspaper, it's not archival. Yeah, but it's cool.
Good for collect dates.
Yeah, totally.
Right. I just want to give thanks for our sponsors for this conference, and in particular, Pest Tech, who's sponsoring this session. And next up, we have Lauren Vonnahme.
All right. Good morning, everyone. My name is Lauren Vonnahme, and I am a senior museum specialist at the American Museum of Natural History in their Department of Herpetology. And I'm here to discuss a workflow for rehousing and digitizing a large skeletal collection to meet archival and accessibility standards. And that's a mouthful. Or my easier title, as I like to call it, The Taming of the Shoebox. Before we begin, I want to acknowledge the lifetime work of the late Margaret Arnold. She was a museum specialist in the Department of Herpetology, and she really developed many of the procedures we're going to discuss here. And she spearheaded the project for the past decade. And there's actually a picture of her training me 10 years ago on this project. So I'm sad she will not see it to completion. Okay, so the American Museum of Natural History was founded in 1869, and over the past 150 years, the herpetology collections have amassed around 400,000 cataloged specimens. And the collection is primarily fluid, as most people's are, but about 9,000 of the specimens are dry osteological material. And this includes things like the skeletons, weird old frog skins and such. Taxidermy that dates back to the original Hall of Reptiles from the 1920s, and my personal favorite, the mummies. As a little mini specimen spotlight, the specimen on your left is it's my favorite specimen in the whole collection. It's a 4,000-year-old accidentally mummified gecko. He looks like a little dried up booger, but he is my favorite because he was pulled out of an Egyptian mummy on accident. So he had a really bad last day. Okay, so we have multiple collection spaces, and currently the dry osteological specimens are housed in what we call the NSB building. This space was built in 2000 and was built specifically to house museum collections. This collection space is in closed cabinetry on rolling compactors, and it was built by Montel, and it's currently upkept by Storage Systems USA. And the dry collection in this the specimens in this collection are sorted taxonomically down through subspecies and then sorted by catalog number within that. And we found that that really works best with the dry specimens because they do tend to spread across multiple cases if we have many of one particular species. And it looks all nice and shiny and new on the outside, but here is some of what we were dealing with on the inside. So, as the collection has grown over the past 150 years, the specimens have been stored in a variety of inappropriate and non-archival containers, such as shoe boxes, cigar boxes wrapped in garbage bags, old newspaper from 1910, just really inappropriate material. And you can see some of the truly heinous conditions we have found on the shelves while working on this project. And I know I am not the only one that has these problems. This photo comes from a dear friend's collection that chose to remain anonymous because they just got donated huge things stored in Bible boxes, which is a little ironic. And so, yeah, so the local Bible college donated them all these extra Bible boxes and they put the bones in them. And right, so I'm not the only one that has like truly terrible conditions. So a physical condition is obviously a problem, but the other issue we were frequently giving us problems was the database. So the staff has not always used a standardized method to codify the types and conditions of the material present in the collection. And this can lead to limited data recorded in the database. So if you look at this screenshot, you can see that the specimens are merely listed as skeleton. This lack of information can lead to it can lead to a lot of issues because if they're listed as skeletons, everyone's going to assume it's a full body when the reality is very different. So this prohibits both collection users and staff from really identifying like research appropriate material just based on the database alone. So if someone is trying to access the database, they might assume that these are full bodies. And we've had a researcher show up to New York City for 2 weeks thinking they're going to look at 100 crocodile bodies. And the reality is we have 4 that meet their criteria. And I don't think I need to explain why this is a huge problem in a very expensive city like New York. So it looks bad for us. It looks bad for them. It's just bad all around. So now what? We obviously have a problem with improper housing and inadequate data accessibility. So how do we go from something like this to something like this? As a way to resolve these problems, we created a workflow for a long-term dry skeletal material rehousing project and have been implementing it in phases over the past 10 years. So let's focus on the workflow. It focuses on 3 main components. The first is going to be rehousing the specimens into appropriate long-term archival storage containers. The second will be digitizing the specimens and integrating these photographs into the publicly available database. And the third will be codifying the osteological material present using a standardized and descriptive language. So how do you set up this kind of large-scale project? We started by prepping lists of all the material listed as skeletons in the database and made corresponding standardized labels to go with them. We amassed a large supply of archival boxes and ethafoam liners. We set up a way to photograph the specimens, and we wrote up a standardized way to codify the bones. And most importantly, we have a dedicated crew of volunteers and interns, primarily from a local high school that does a year-long work study with us every year, where a couple students come 1 day a week all day to volunteer and intern in the collections. And so this is a project they really enjoyed working on. As I said earlier, we have our skeletal collection sorted taxonomically and numerically within species. For a project in a collection of this size, we found it easiest just to start on one end of the collection and work our way through it taxonomically. For example, we started with the amphibians just because we have so few of them. And since we don't have very many, it was easy to prep this material when we were getting started. So I would have everything set up and prepared for the interns. And I found it easiest to pull 1 tray of specimens at a time and have them work through the checklist with these 1 tray of specimens. And then when they were they would work through the 3 goals of rehousing, digitizing, and codifying 1 tray at a time. And this was really easy since the specimens are stored in order. So I found this was really the best way to implement this. Okay, so the first aspect of the workflow is to rehouse the specimens into appropriate storage. This step is fairly obvious in its execution. Specimens are removed from their old housing and placed into new appropriately sized boxes. We currently use boxes from Althor, Durfee, and Conservation Resources and have used other vendors in the past. And we prefer the clear polystyrene boxes as it makes it much easier to browse the collections. However, I have heard that some collections do not like to use the polystyrene boxes either for fire safety issues or the yellowing and warping of boxes. So the polystyrene boxes can warp in the presence of benzene rings, and this is usually found in things like chemical cleaning agents or naphthalene mothballs. Our collection is in closed cabinetry, and we have had absolutely no issues with yellowing or warping over the past 10 years this project has been in place, and things that were stored prior to that in plastic boxes. And I think it really has to do with the closed cabinetry. So if you have open cabinetry and you are worried about cleaning agents, or you still use naphthalene, which I think is banned, so hopefully you shouldn't, you might want to use the archival acid-free paper boxes. It just isn't as easy to browse the collection. And so the new boxes and the trays are also lined with ethafoam liner just to prevent damage from vibrations because they are on rolling compactors, etc. So if something is complete and articulated, it can just sit inside the new box. And depending on the level of disarticulation and the size of the bones, the specimens may need to be broken down into smaller boxes within those boxes. I try not to have anything larger than a 3 square inch box on the shelf. And anything smaller than that may, you want to, as you can see in these pictures, you can break it down into smaller things. Extra tiny bones, we actually use gelatin capsules to store and then put that within a smaller box within the bigger box. And anytime it was required to break these down into multiple smaller boxes, we add another tiny printed catalog number into these smaller boxes in case it ever gets separated so you can reassociate it in the future without issues. And all of our bones should be labeled as well. Whenever we get new specimens in, we write the numbers on the bones. So standardized labels are then added to the main box. One of my postdocs actually wrote me a script in R to easily make labels very quickly. A lot of databasing systems will generate these labels for you automatically. There are other ways to do it online, but if you have a small collection, you can even do this by hand. As a side note, this project is being run by a constantly changing team of volunteers and interns. We have added multiple checkpoints throughout the workflow in order to lessen the chance of mistakes being made. So for example, after they rehouse these specimens, they leave the old boxes aside for me to check to look for any errors. And I wish I could say there's no issues, but I have found tiny bones stuck in cracks, occasionally a missed catalog tag, and one time an entire alligator foot. I don't know how they did that one, but this is a really good point to double check the work before you throw away these old boxes. And oversized articulated specimens that cannot fit in boxes are left on the shelf as is with a little extra ethofoam padding around pressure points if needed. And if they have smaller bones that go with it, we just put it in a box next to the specimens, as you can see in some of these oversized turtle preps. Okay, so the second component is digitizing the specimens and integrating these photographs into the database. While the interns are rehousing the specimens, we're having them take a quick reference photograph to attach to the database. I do most of the photography for the photography request for the department, so I actually have a decent copy stand setup that's attached to remote activated DSLR. I think it's an important skill for people to learn how to use a camera on manual, but if you're not camera savvy or you don't want to let interns be handling expensive equipment, you can easily use a cell phone. Everyone has an iPhone. Those pictures work just fine for inventory photographs. So the photographs will include the specimen's bones laid out nicely, a scale bar, and the label. We try to aim for 1 photograph per specimen, but sometimes it's necessary to take multiple photographs. At the end of each day, the photographs are uploaded to a computer where they are minorly edited, usually things for cropping, straightening white balance, and the files are all renamed in a standardized way. I have photography experience, so I prefer to use Adobe Lightroom for this, but you can easily use the free photo editing software on your computer if you feel the need to crop the photos. And this is another good place to do a proofing checkpoint and confirm that the photograph has a scale bar and is not blurry. That happens. And that the label, the catalog tag, and the file name all match. The photographs can then be uploaded to the database, either individually or in a large batch import, and you now have a reference photo attached to the record that pops up when the specimen is searched for. So if you're looking up this turtle record, you can see that there's a easy inventory photo next to it. The third component is going to be codifying the osteological material present using standardized descriptive language. So in order to accurately update the database, the interns would be given a printout that matches the order of the specimens on the shelves, and then they mark the specimens as complete or incomplete, semi-articulated, disarticulated, or articulated, and whether or not the specimen included cranial, axial, and appendicular bones to the best of their ability. We obviously don't expect them to know every single bone off the top of their head, so we give them nice little cheat sheets, and honestly, it's pretty obvious whether its head is there or its legs are there. So they really do it to the best of their ability, and it's been working well so far. This is another good place to do a checkpoint. Since the printout is from what our database says is dry material, it should match exactly to what is pulled. So if something is missing, we can try to figure out why. Or if something is there that isn't on the list, we can try to figure out why it was incorrectly marked in the database in the first place. So remember the terrible database labeling from the beginning? We use the interns list to update the the database to reflect what is actually present, written in a standardized way, which results in much more accurate search results for researchers utilizing the database and us staff. So it's now obvious which bones are present and in which condition. So if you look here, this is a turtle specimen. It is a skeleton. It has appendicular and axial bones. It is complete. It is semi-articulated. It is obvious what is there. And if you go to the multimedia tab, it will show the attached photograph. And all of this is in EMU. We use EMU as our database. So to date, we have rehoused about 50% of the entire collection. I know I'm going to get asked this question, and I do not know how long it takes to complete this project. The reality is different specimens will take minimal amount of time. Some may be more complex. This is also a long-term background project. We don't work on this consistently. It's really when we have extra volunteers and interns that are interested in working on this. Also, boxes are expensive. So we restock the boxes at the end of each year with whatever's left of the fiscal year budget. Some years we may be able to get a lot, some years we may not. So this is really just a long-term background project that we're slowly working through. But the workflow that we're presenting here is really providing a best practices platform that you can implement yourself, both to rehouse your current collections and adhere to the same set of standards for anything incoming. Thanks to everyone past, present, future in the Department of Herpetology. And if you have any questions, you can email me, but I also have cards, so you can come grab me after the talk and I can send you my the scripts or the vendors, etc. Any questions you may have. Thank you.
Is Grace DeVault here? Oh, perfect. Wonderful. Thank you so much. I'd like to announce our next speaker, Grace DeVault, talking on one big micro problem.
All right. Hello, my name is Grace, and I'm the Paleontology Collections Assistant at the Science Museum in Minnesota. And today I'm going to talk about some problems we ran into and some solutions we found for dealing with part of our microfossil collection. So a little bit of background information. I was hired to digitize our Wanagan Creek collection. It's 60 million years old from western North Dakota. And it contains a lot of different types of animals and plants. There's fish, reptiles, birds, mammals, amphibians. There's even fungus fossils there, which is really cool. And the macrofossil material is in pretty decent shape. It consists of a lot of crocodiles, like these skulls right here, that are labeled. They have nice housing, like these cavity mounts or the jackets. But the microfossils were in a little bit different stage of curation when I first got to them. But they do contain a similar amount of diversity as the macrofossil material. There's all different kinds of vertebrates like birds, mammals, reptiles. There's invertebrates, insects, ostracods, gastropods, and there's a whole bunch of plant material in the form of pollen and megaspores. So it's definitely a really important part of the Wanagan Creek collection. So we want to make sure it's in just as good a shape as the macrofossil material. So when I got to this collection, we had some geologic material that had been collected for either pollen or microfossil sample processing, but it hadn't yet been processed. So it was still in these envelopes or bags. And we had several boxes that contained glass slides that had a specimen and a cover slip glued down on them. And then we had a couple of these large wooden boxes that were full of trays that contained 12 or so slides on them. These are more of the cardboard well slides where there's a piece of cardboard with a little well cut in it for the specimen and a glass slide on top of that. And then we also had some of these boxes of loose slides. They'd actually been on loan to another institution for 30 years or so, and we got them back. And we definitely wanted to make sure that they were no longer at risk for losing any specimens or the information that had been attached to the slide at some point. So these ones especially, but all of the slides were in need of solutions for cataloging and for labeling and for storage of this material to keep it in as good a shape as we can. So a little bit of background before I talk about how we cataloged this material. These are the Science Museum of Minnesota catalog numbers. They start with SMM for the Science Museum of Minnesota, and then P for the Paleontology collection. And then this is followed by 3 different numbers. The first being the year that this material was accessioned. The second being the number of that accession within that year. So this would be the 20th accession from 1970. And then the last number is the number of that item within the accession. So this is the 100th item accessioned in P7020. And then we do have a special case scenario, a special case accession, FIC, which stands for found in collections. And this is for material that we find that we can't immediately find a catalog number for, but we want to make sure that it is labeled with a number so that we can come back and find it. So these are temporary numbers that will eventually be replaced by catalog numbers once we figure that information out. The second number, again, this is the first found in collections accession, and the last number is still the number of this item within that accession. So with that information, we decided to take those geologic samples that hadn't yet been processed and use that found in collections accession to catalog them as geology material. And then in the future, when they do get processed, the paleontology material will be given permanent catalog numbers and be put in our paleontology database. And then we realized that the material specifically that was in those large wooden boxes had actually been given an accession, but had not been cataloged for whatever reason. So P2010.8 was the accession for that material. So we just started at 2010.8.1 and cataloged that material that way. And then there were several groups that were those slides loose in the boxes that we brought back from another institution where they had been cataloged in lots taxonomically. So these are all Azolla plants and they have P7913.1, but we wanted to be able to differentiate individual slides for research purposes. So we added a 4th number to the catalog number. So the one that's in the red square up there is 7913.1 470. When there were slide numbers on the slides, that was the number that we used for that 4th number. But if not, we just arbitrarily started at 1,000 and went forward from there so that we didn't duplicate any slide numbers that did exist. And then if none of that information applied to the specimen, we simply used the found in collections accession and cataloged the slides from there. And then as far as labeling the slides goes, we wanted to find a fairly inexpensive and also temporary labeling system. A lot of these slides are going to end up either getting rehoused and or renumbered at some point. So we wanted to just kind of have the cheap and temporary option for that. So we found these white mailing labels, and specifically the 1/2 inch by 3/4 inch size fit really well on the slides. So we just use micron pen to write out the number. They stick pretty well. If they do get peeled up, they will not stick back down, but as long as they don't get peeled up, they stay on. And then finally, storage. So this was most important for those slides that were loose in the boxes. So what we ended up using as our storage method was we had some 12 by 18 white archival boxes, and we cut sheets of blue board, or in some cases the plastic board, depending on what we had in excess in the lab, to the shape of those boxes. And the end goal is to stack these sheets on top of each other inside of the box. So we ended up outlining the sheets with 1/4 inch foam backing rod. And the reason we used 1/4 inch was that it's a little bit taller than the slides themselves. So when these sheets get stacked on top of each other, they're sitting on the foam and not on the slides. Once we had the sheets outlined, we then divided them into columns, again with the foam backing rod. And those are the width of a slide. And then we separated those columns into little cubbies for each of the slides using different materials that we just had around in the conservation lab. And we were sure to leave little openings in the center to make it really easy to pick up and set down the slides so that there weren't any issues with like jostling specimens as we moved them. So you can see in picture number 3 on the top there, we used just hot glue for that one. It's fairly inexpensive materials wise. Hot glue is a bit of a pain to work with, so definitely wasn't my favorite method that we used, but it does work. The slides definitely do stay in place. The other picture on the top, number 4, we had a bunch of extra brass fasteners, and so we decided to try and use those. And they worked really well with the plastic board specifically, where we just poked a bunch of holes into the plastic board using an awl, and push the fasteners through, bend them forward, and they hold the slides really well in place. So that was probably one of my favorite methods that we ended up using. Number 5 is another really easy one to use. We just used the 1/4-inch foam backer rod, hot gluing it down. But you do still have to spend the time to cut out those little pieces of the foam backer rod. So it does take some time to make that one as well. And then finally, number 6, the other one on the bottom there, we took the time to measure out and make little templates using the measurements of a slide, and we cut it out of extra blue board or plastic board. That one is also a bit time consuming. It's hard to get those exact measurements cut out, and some of the little arms tend to break off, but it also is a method that works. But while we were working on all of these, I was working with a volunteer, and he had some friends who worked in laser cutting and was interested in kind of brainstorming some ways to possibly make some laser cut slide dividers to make this a little bit less time consuming. And so we threw a bunch of different ideas around, and this is the final design that we came up with. So in the first image there are the measurements that we used for these slide dividers, and they are cut out of 1/4-inch acrylic for the same reason that we use the 1/4-inch ethafoam to make sure that it's a little bit taller than the slide. And the second image is how these different slide dividers line up together when we go to laser cut them out of a sheet of acrylic. And that's kind of the main reason that we went with this design, where the slides are now stored vertically rather than horizontally, is that we can print a lot or cut out a lot of these different slide dividers in one sheet of acrylic. So we get a lot more slides stored out of the same piece of acrylic. So number 3 is our first prototype there using these acrylic dividers. Since they are all cut out separately, we do still run into the issue of making sure they all get lined up so that they store the slides correctly. Since the arms are pretty short, you don't want to have too much extra space there. So we did end up creating the template that you see in number 4 to make sure we get them lined up across the top and the bottom. But this is another idea that we did try at one point, but decided not to go with, where this is all one piece of acrylic. So the slides are again stored horizontally. So if you cut this out, you can just take it and glue it right down to the blue board or the plastic board, and you're ready to go. But since it wastes so much acrylic, we decided not to go with this method, but this would probably be the fastest method. But regardless of which slide storage method we chose, we ended up with a bunch of very happy slides. They're stored, they're labeled, they're cataloged and digitized, and they should be ready for research in the future. So with that, I would like to thank Mark Schaberg, who is the volunteer who helped me to design all of the different slide storage methods. Susan Schaberg and Jacob Kramer helped with the laser cutting and kind of testing some prototypes. I'd like to thank Charlie Iverson, the registrar at the Science Museum, who helped with a lot of questions on digitizing, and IMLS for funding this project. And I would love to take any questions.
Last one. So how many sheets can you fit within a box?
4-ish. It gets a little bit taller than the box.
Yeah. And how many slides is that?
That's a good question. I think on average we get about 36 to 40 per sheet. So it works pretty well. And the nice thing about all these different methods too is we can also scale them down to different boxes to eventually put this away taxonomically. So like things that we don't have as much of can then fit smaller places.
Well, thank you. The question is, are you getting rid of the wooden slide cabinets?
Eventually. We definitely don't want to have the wood in the collections, but there are a lot of slides in those, so through time.
Excuse me. Obviously, making slide holders out of scrap blue board and things is economical, but with the laser cutting and things like that, how did that compare cost-wise to pre-made, pre-bought, commercially available slide holders?
Way cheaper. We did look at commercially available ones. There are a lot that are available for storing slides vertically. but especially for the well slides, we didn't want to use those because then we're at risk of losing the specimen. I do not remember the prices offhand, but we looked at those before this and decided it was cost prohibitive.
While you were evaluating the collection, did you find any slides that were degraded over time? Did you make any assessment? And how did you assess the quality of the slides?
Yeah, I think I'm running out of time, but real quick, I will say that there were some that are held to, or actually there's a lot that are held together with Scotch tape. So that's less than ideal. So as of right now, it's kind of just noted in the database that like slides need help, and that will be something that we will address in the future. So we're just like adding like painter's tape to hold things together at the moment. Luckily, most of them are in pretty good shape.
So I stole all these slide animations from somebody else, so I apologize if they're very out of order. But also, you don't need to know my title. You don't need to know what this talk is about. Just focus on all the really cool specimens you just saw, and then sort of imagine what the data looks like. But you do need to know my really wonderful collaborator who can't be here, Katie Saunders, who is our archaeology records manager. So we saw all these really, really wonderful specimens. And I know all of us, no matter how big or how small we are, have had two things happen to us over the course of our careers. One is we've opened up a desk drawer of somebody who's left and found all these documents relating to what our wonderful collections are, our field photos of people asleep in wheelbarrows. And we've also gotten the endless parade of emails from social media and marketing being like, hey, I heard you have things. Do you have cool pictures of those? When we all know we've sent them that like a year ago, and they're like, you lost this already? So I'm making the case for building in as part of your digitization projects a sort of shared metadata structure, and in this case specifically with your archaeological and paleontological collections, because a lot of those concerns are similar, especially when it comes to access sharing and restrictions. And we all have like a million images of really cool things, but the more challenging part is always figuring out how do we take those images and reconnect them with our things or expeditions or whatever. My collection staff will tell you they're probably tired of me bugging them about this. So, actual slide. So a little bit about our archives, but not archives. I will be yelled at by our registration department if I call it an archive. So there is no central museum, archive, or library. We do connect a lot with our on-campus libraries, the Marriott libraries, and yes, it is those hotel Marriotts. They're the same people, I've been told. Somebody will correct me. But every research division, including registration, maintains a small collection of associated documents. Another loaded term, that's a debate for another talk. But these materials primarily cover collecting activities and or work on those collections, and et cetera, et cetera, et cetera, et cetera. These include everything from paper documents, large maps, photographic slides, glass plate negatives, transparencies, X-ray printouts of CT scans, everything you can possibly want and more. And much of this documentation at our museum has both been generated since our museum formed in the 60s, but a lot of it even predates our museum, and some of it even from the very beginning of our university in the 1860s. You dig enough in your archives, you'll find some really weird things and some really wonderful things. So I apologize in advance. These are the most pictures you'll see in one slide in my entire talk. It's difficult to talk about metadata while just showing really cool pictures of things, and all I want to do is show pictures of things. Okay, so metadata infrastructure and planning, yay! It's actually really exciting, or I'm trying to make it exciting. So these are the key concepts in mind when you are planning your metadata infrastructure. And it's great to mirror what other people are doing, but that may not be perfect for your institution or where you are at in your data management process. And so if you are moving into a DAMS or into a different file management system, these are things you really need to think about and consider, and things I'll walk you through in my case studies following this. And so my first thing I have to tell you, because I've told this to anybody who will listen, digital asset management systems aren't collections management systems, nor do they need to be. Not everything that's in your collections management system needs to be in your digital asset management system. What's in your digital asset management system should mirror your document archives. And if you don't have some sort of organizational structure, take the time to do it. It really does help, I promise. So you're not like looking for a single quarry map out of like 5,000. And a lot of your digital asset management structure should be based on core key questions. Who is looking for this information? How are they going to look for this? Because we all know the scientific names for like, you know, Archaeopteryx, or I can't think of any scientific names, or like archaeological sites. But I can guarantee you that as soon as you say the word Echinocephalus, your marketing team is going to forget that or like add 5 different vowels. So how are these different key stakeholders going to look to or connect to your records? And does this material relate to other institutions? As museums change and grow, as universities change and grow, you'll find that you really judge the choices people made before you. Like, why is this huge, great document archive that's about our collections stored at the library or the State Historical Society or in the museums in Paris? What is sort of this chain of custody that are only in these written documents? How is this material going to be uploaded and managed in your digital infrastructure? And that's a whole thing. And what is the action plan for implementing all your great metadata that you've just created throughout this entire process? It's great to have a plan, but how are you going to do that plan? That is a key step. Okay, so this is sort of a bare bones of a digital asset management infrastructure. Yay, exciting flowcharts. I didn't make this. I make other flowcharts that are way less interesting with too many steps. So basically, you've got your stuff. And this is our digital asset management system created through our university with a very unfortunate tool name for anybody who's like a millennial. And so basically what happens is you have your digital content, you have your information about your digital content. Within the SIMP tool, you create your metadata, you make it into a really nice package, you associate it, you add more stuff, you take away stuff, and then you send it to Rosetta or Ex Libris Rosetta, which is the backbone, like archival storage management part of this that you really never see, and to SOFAL, which is sort of our library's derivative for sharing these in a really unique way, which is good if these things may not directly connect to the way you display things in your collections management system, or if your collections management system is too complicated to display things in. But another thing to really, really, really consider, especially for archaeology and paleontology collections or the data restrictions. And so these can be things like not being allowed to share sites or images of sites in consideration for the NAGPRA. And I tried to find some symbol for paleo rules, so I just found a book of rules. They don't have a cool symbol like NAGPRA. Get on it, guys. But also, how do other people want to connect and share these? Because people are generating these documents, researchers, and they may want to limit or manage things differently than the way you really want to. And until something happens to change their mind, you can't really do anything about it. Or you can and just not tell them about it until later, and they're like, oh, this is great. I'm like, yes, I told you this. So, case study 1. Now we're getting to cool pictures. My colleague Katie is the one to blame and to thank for all of this. So these are all our archaeological records. They're about 100,000 plus records for collecting across the state of Utah over time. They're everything from documents to floppy disks to dot matrix paper to everything you can possibly want and more. And so the first stage in any mass digitization project as it relates to documents is figuring out what you have, which is really important. I can't tell you how many times something's been started and you don't know what it is. But also, what is the most utilized or most underutilized parts of that archive or collection of things? And in this case, it was our color slide collection. So I don't know if you've ever seen a color slide, but they're like, maybe this is just people of my generation, but they're like 2 inches by 2 inches, little photographic slides you have to scan like one by one. It can take forever, but these are vastly important records of archaeological sites and locations in Utah that no longer exist. A lot of these were created through the action of surveying to build reservoirs in dams, and then they changed the landscape so that they're no longer there. They also degrade over time, but that's less cool an explanation than the landscape change thing. And so I think I prefaced this with photos to prepare you for all the data and spreadsheets and the lists, so enjoy this while it lasts. But there are these really cool photos of both a historical record and an environmental record of the landscape that we do have to be careful about sharing these images, but they are important to science. Because sometimes you get scientists who write very bad descriptions of things. I'm sure nobody has encountered this ever, right? And so our first step in preparation for our digital infrastructure was to create a finding aid. And this is a wonderful first step if you don't have the capacity to sort of do this huge metadata spreadsheet. You can get this online and searchable quickly in a variety of different ways. For historical researchers and scientists, we use Mountains West as an archive. And these are our stakeholders. There are probably more, but I forgot to ask. So a bunch of different people use and share data similarly to us, but also in material that relates to us. And so these are the people we had to keep in mind and ask and sometimes ignore their suggestions. I mean that in the kindest way. But we did manage to develop some really robust workflows for both handling our backlog of historical documents, but also to process things as they're coming in. So I can proudly say we have like no backlog of document processing in our archaeological collections, which is like awesome. But I may also be a nerd. But these are some of the steps in the workflows. They're more robust, like some of the cool workflows we saw earlier. Kudos to you guys. But these are the basics of how we get things in the system quickly and efficiently, and eventually relate them back to their either excavation trips or more. And then eventually they get shared in EMU. I always want to share instances of our EMU because they all look vastly different across the different collections management systems. So everything gets a media record, and if we can relate it, we will relate it, but not all of this gets related. That's also another talk. And then it gets shared in our digital asset management system where you can search for like a person and find everything over that person's collecting career. So we have sometimes just looked for like Jim Madsen, one of the many, and found everything that relates to his collecting career that relates back to objects, and then found objects for people that were lost, and it's a whole thing. So this is our most complete project for digital data infrastructure. This is one that's slightly less complete, but also really cool. I'm working on it, I promise. So these are archives of paleontology data and quarry maps and other things. They're all really cool, some really suspect. And these are some of our stakeholders. So with archaeology collections, you also have permitted researchers, the many land agencies who want proper attribution, rightfully for some of their things, the libraries and related area museums, some of which are here. And connecting to these different places are important because we also exist to help support them. Yeah, more related materials. Apparently, I really liked related materials for this. But we are still, because we are still on the beginning stages and we can build off the successes of other parts in our museum, we can sort of look through and plan our metadata structure to match similarly, which means once this all gets dumped into one sort of giant bucket, then we can search how our different collections relate, because often these expeditions don't exist separately in time and space. And I'd be more than willing to share with you our lovely file naming procedures. I made a decision tree with our collections manager, and I'm very proud of it. But everything gets a unique file name that either relates to sort of a hierarchy of importance or a hierarchy of what we can actually find and relate back to those things. I'm going to make a pitch for also just making really good notes. Field notes are important. So we're starting to plan, how do we relate these files in EMU if they're not direct trips, if we don't collect anything? How do we deal when people suddenly like, hey, I've got like a ton of fossils that I need to drop off at your museum that I collected in 2014 and meant to give you, but never did? Versus the trips that we actually go on and actually collect, and differentiating between those two, because it's kind of different when we collect versus others. And processing all the many photos. We do have a pretty robust metadata template for field photos that I have to sit down our curator and make him go through one by one, telling me everything about his photos. So I'm sorry if you've collected in Utah. I probably know too much about you. I apologize in advance. But there are a lot of next steps to sort of starting to integrate this with all the different collections that operate out of our museum and all the different stakeholders, including libraries, other museums, and starting to reconcile 3D metadata infrastructure. So I recommend sort of taking a hard look. I'll send you any documentation and metadata templates you want, the more the merrier, but really starting to walk through these questions yourself with your staff, because it's a negotiation, and having to go through those steps yourself, in addition to having those templates, can be really helpful to inform your process. And I'd like to thank all these people who are awesome and great. If you see them, thank them yourself. Some of them are here. Yeah, so I don't know if we have time for questions, or if you want to ask questions.
I had a question. If there's time, is there time?
Find me later.
Hello, everyone. Happy first day of Pride Month. I am Kelsey Brown. I'm a curatorial assistant at the New York Botanical Garden. Laura could not be with us in person today, but I would like to talk to you about from finding frass to plotting points, transforming from a reactive to proactive IPM program. So integrated pest management was popularized in the 1970s as a way of using a combination of methods to look at pest concerns so that we might reduce our reliance on pesticides. So this includes things like exclusion, monitoring, identification, and solutions such as isolation, bagging, freezing, etc., before we resort to the pesticide treatments. And so this might help us remedy any pest situations before they can do unchecked irreversible damage. In 2020, the William and Linda Steer Herbarium committed to identifying and recording all pests caught on traps, and we expanded our monitoring efforts. Before this, pheromone traps were used and opportunistically checked, but were not recorded. Anything leaving or entering our herbarium was frozen thoroughly, but this does not stop crawling pests from entering our herbarium. So now in 2023, we have 94 traps that are collected and replaced quarterly. And everything that is found on those traps is diligently recorded. And we have accumulated enough data to be able to see seasonal trends in our collection. But with just a small IPM team of 3 people, it has been a challenge to apply this data effectively and proactively, as all of us who are on the IPM team have full-time jobs in the herbarium unrelated to IPM, and therefore it's very much just a labor of love, both from a desire to want to protect our collections for future use and just an interest in the bugs themselves. So we come to this issue of how can a collection with 7.8 million specimens go about implementing IPM effectively with limited resources? To give you an idea of what we are working with, this is what a typical trap placement looks like on one floor of our herbarium. We have 4 herbarium floors monitored in this way, as well as 15 additional office spaces, our mounting room, sorting room, our shipping office, as well as our temporary holding space for orphan herbaria. We use 3 different types of traps. One is the blender trap, which opportunistically catches anything that happens across it. These are usually placed in the entryways, as well as along walls and along central columns. We also use cigarette beetle traps, which are a pheromone trap, which is hanging and attracts just male cigarette beetles. And then we also use a domestic trap, which is baited with food, which attracts all domestic beetles, but we've also found that it is very good at attracting silverfish and spider beetles as well. So as a first step in making our efforts more effective, we started by understanding what is in our collection and trying to keep all staff informed and able to recognize problem pests. So we created these posters, which are now hanging on every floor of our herbarium so that anyone visiting the collection can know what to keep an eye out for. And we also added door sweeps to all herbarium entrances to reduce the number of crawling pests getting inside. While our monitoring efforts have greatly increased the staff knowledge of pests and helped us to understand what is inhabiting our collections, identifying what we have is not directly reducing the number of pests in our collection, as knowing is only half the battle. So we continue to find odd beetles, which many of you may be familiar with, as they are often referred to as museum nuisance beetles. Luckily for our herbarium, they are not a great threat to our collection, as they more often feed on furs and skins, so they're a greater threat to animal collections. But they are having the time of their lives feeding on other pests that are found in our collection. Our greatest nemesis is the cigarette beetle. The larvae of these insects are often called bookworms. They very aggressively eat through paper and plant materials and will reduce them to dust if left unchecked. Unfortunately, in January of this year, we had a run-in with the cigarette beetles when our assistant curator was opening a cabinet and found a small infestation of them. These particular collections, which were in the APAC, had not been used for a little while, and so it's likely the cigarette beetles had been there for quite some time. We were aware that they were present on the floor, but they were not being caught in large enough numbers to raise a significant alarm. That same month, there was only one caught at the vestibule, and then 2 in the pheromone traps near where the infestation was ultimately found. But because these pheromone traps attract the males specifically, it did not raise enough of an alarm at the time to let us know that it was in that exact area. So we have this data, but we're not really applying it. We know the insects are present, but we're having a hard time pinpointing these problem locations before it's too late. And this results in time-consuming specimen cleaning and pesticide treatments if it's severe enough. So that run-in with the cigarette beetles, this is what the cleaning process looked like for that infestation found in January. The cabinet had been left undisturbed for so long that the cigarette beetles had lived out multiple life cycles and left behind quite a bit of frass, as you can see in one of these specimen folders. In this case, unfortunately, most of the reproductive structures had been eaten, but thankfully only a couple specimens were this badly damaged and most were able to be saved. But you can imagine the time and resources it would take to remedy a larger infestation. So we were starting to feel a bit dejected that we were not actively reducing the number of pests in our collection. And so we decided to turn to the literature to hopefully find some help. And thankfully, we came across a 2019 presentation by Christian Bars and Jane Henderson, which provided a helpful template for us. It was called Novel Ways of Communicating Museum Pest Monitoring Data. And in this presentation and their subsequent paper, they introduced what they called the Pest Occurrence Index, or POI. And the POI allows us to apply our data more effectively by using a simple formula that takes into account the size of the space, number of traps, and time between the pest checks. So Bars and Henderson gave us a solid base, but because of the pests we're not concerned about, such as Dinarella, which is a fungus beetle that does not directly affect our collections, their POI tended to overestimate our personal risk tolerance. So this top line in red that you can see here is what our data looks like if we use Bars and Henderson's formula unmodified. But again, because we have limited time and resources, we decided to modify their formula into a weighted formula that also takes into account high risk, moderate risk, low risk, or simply environmental indicator species. So you can see on the bottom, that blue line is now what our data looks like with the weighted formula. And so this allows us to really prioritize those most at-risk portions of our collection. And we also drafted some action plans based on these as well. The criteria came from Bars and Henderson, but we created the plans ourselves. So in that red zone, if the POI is greater than 0.1, that's our high alert. At that point, it is very much a reactive. It is too late to be proactive at that point. So we would do a deep clean of the floor. And if there is an active infestation, everything that is affected would get frozen. And if severe enough, we will also do a pesticide treatment. When we do that, we use a mild pesticide called Ecovia, which is naturally derived, mostly made up of thyme oil. In the yellow phase, that is our medium threat alert. So in those cases, we will do a deep clean of the floor and also check the envelope to make sure that there are no cracks or crevices that the insects might be getting in through. And green is our maintenance phase. That is low threat. We'll just continue monitoring and adjust as necessary. So Most floors for us, thankfully, hover in that green zone. IPSC is just the name of our building that the herbarium is housed in, and our herbarium is on floors 1, 2, 3, and 5. So that is why you only see IPSC 1, 2, 3, and 5 there, and there's no 4th floor. So most of our floors are thankfully in that green zone, with the exception of the 1st floor, where more crawling insects are able to get in. And so this guy, the odd beetle, has plenty of food to eat from the bugs that are just crawling in from the outside. But again, thankfully, they're not a great threat to our specimens, but we do still like to track them. So before our most recent check, we implemented our action plans, and we started with the 1st floor. We did a deep clean of the floor, and the results really exceeded our wildest dreams. We were able to reduce the POI of the 1st floor lower than it had been in the nearly 3 years that we've been monitoring, just from enacting that protocol. And it is a little soon to, be very excited, as it could be a fluke since we've only done 1 check since this happened. But nonetheless, we're very hopeful that these results will continue. The overall pests of our collections did not reduce very greatly, as you can see on the right side axis and represented by that blue line. That was mostly due to environmental indicator species, though, that are not a direct threat to our collection. And we are still celebrating a little bit because in the columns, you can see the POI, as I just said, greatly reduced just from that initial response. So again, it is too early to claim success in transitioning from a reactive IPM strategy to a proactive, integrated, preventative pest management, but we are hopeful with our initial observations and thankful for the work of this community. So we invite you all to think about your own collections. If you think you are exempt from pest concerns, think again. 27% of all collections report pests as a source of loss, and that number jumps to 54% for scientific collections. So think about your own collections. Are you being proactive? Are you being reactive? Are you collecting data about the pests that you're finding? And if you are you making it as useful as possible for your collections? And if not, how can you start? So, I was very happy to see Margo and I use the same thank you. This comes from the ABCs of the Herbarium, which my lovely colleague Amy Weiss put together. You can find it on our hand lens. But yeah, so we'd like to thank all of our colleagues at the William and Linda Steer Herbarium, as well as our interns who always report any pest they see, which we're very grateful for. Christian Bars and Jane Henderson for giving us some hope in dark times. And then our go-to entomologist, Patrick Kelly, and museumpest.net, which all of you should check out if you haven't. It is a great resource. And of course, all of you as well.
So I saw you talked a lot about insect pests. Do you find any other rodents or?
Not particularly. We will occasionally find a single mouse in our more kitchen areas, but not anywhere near the collections, thankfully. Yeah.
Excellent final slide. I am curious, if you work with your institution's operations team, because I know at my botanic garden, they have their own IPM stuff, and it's 100% separate from my own IPM stuff. And do you work together? How do you do that? Does it work?
Right. So as far as the monitoring goes, our operations do have an external pest source that places traps, but anecdotally, I've seen them come through and kind of just step on their trap and throw it away. They don't, exactly track what is on the traps. So our traps are completely separate that we monitor from. We do work with operations so that they'll do regular cleaning of floors. But yeah, overall, our pest management is a bit separate, but we're trying to collaborate as much as possible.
How often do you recommend floors are cleaned? I'm guessing sweeping and mopping.
We don't go as far as mopping, just like sweeping and vacuuming. But the more the better. We have operations come through at least weekly to do our vacuuming, and then if we have those issues that we see with the high POI, then we'll go through ourselves and do like all of the cracks and crevices, try to get up any debris, anything that's maybe fallen under the compactors. But so more is always better. But yeah, at least weekly is ideal, I would say.
Yeah, we have linoleum in our collection areas, and I think they will wax those too. So I don't know if that would help or not.
I'm not sure about the waxing, but
okay. Thank you.
That more. More questions?
I'm curious if you have been successful with, I feel like sometimes you'll look at the blunders and maybe see heightened activity, maybe in a quadrant of the collection room. Have you been successful in then sort of tracing and pinpointing a source of infestation, or what do you do if you sort of notice peak activity and really can't, necessarily track down?
Yeah, so we've had some trouble trying to pinpoint things because we have 7.8 million specimens spread across 4 floors. So ideally we'd be able to like open every single cabinet door, and look for evidence of the pests. But that's not feasible. Ideally we could have like someone who's full-time doing IPM, but that's just not feasible for us at the moment. So we do our best to track them where we can. But as you saw with cigarette beetles, we really weren't getting a large signal from them, and yet they were there all along. So it's just, doing your best to try to track them down based on what we're seeing. But it's not always super easy to pinpoint. I don't know if that answer your question.
Since you have so many floors and so many cabinets, are there families that you target to keep an eye on more closely than others, like APAC?
Yeah, so the cigarette beetles really like those thick woody things we've found. So we typically keep an eye, especially on like Caseria. We've had some historical infestations in Caseria, so we always keep an eye on those, and any things that have similar structure. And then with the APAC, what we saw were that they were really liking the highly branched specimens because it was really good for them to lay their eggs in, and the larvae just had so much food source available, and then like the pupae were able to be protected in those highly branched areas. So they definitely do seem to like certain areas more than others. They are also usually called tobacco beetles because they tend to also like tobacco. But yeah, it's more anecdotal at this point of what we try to look out for.
And I have one more question.
Yeah.
When you do the vacuuming, does you said your custodial staff helps with the vacuuming weekly, and do they or whoever vacuums, do they do just the floors and the tracks for the compactors, or do you ever do inside the cabinets in the catchments at the base of the doors?
Yeah, so the custodians come through and do just like the general floor, and then we'll go through with our handy dandy super fun vacuum that I have named Henry. And we'll use that vacuum to like very targetedly go into the tracks, and then also open any cabinets that might have debris at the bottom and try to vacuum up those areas. So we do the more like intense vacuuming, and then like there's the overall cleaning that the custodians do.
And how often do you do the more intense vacuuming?
So anytime that we notice debris, we try to do that. I know we're running low on time, but anytime we notice debris, we try to come in through with our vacuum and get that all up. And then otherwise, it's just if we see a signal through the POI.
Okay.
Yeah.
Thanks.
Cool. Thanks. Well, thank you again to all of our presenters. This has been wonderful. Again, big thanks to our sponsors, Delta Designs and Picture. We are headed into a half-an-hour break, so we will reconvene at 10:30 and continue on with this session. So thanks for attending. All right, folks, welcome back. I know people are trickling in from the break, but we've got our virtual folks online, so we're just going to be timely and get started. So welcome back to the Back to Basics Museum Techniques Skillshare, Part 2. So we continue on. I'd like to thank our sponsors for this conference and our diamond level sponsors, Picture A and Delta Designs Limited, and our sponsor for this specific symposium, Pest Tech. Thank you to all. And I'd like to introduce our first speaker of this late morning, Fran Ritchie, who's going to talk to us about how to B72. So thank you.
All right, thanks you all. That was such a fantastic break. So I'm not surprised that people are still trickling in from it. So I'm an art conservator for the National Park Service. And part of my job is to either go to parks and work on their preservation projects, or they send the items to me to work on. So we're a service center, Harpers Ferry Center, and we service any national park in the United States. For example, last week I was working on some leather furniture from Eisenhower, while also responding to emails from Rocky Mountain National Park about coming to clean their taxidermy. So as a service center, I also am emailed many questions on what to do for kind of anything related to the preservation of museum collections, including how to reconstitute your B72 if it's dried up in bottles, or how to make it, or things like that. So I thought I would go ahead and submit this talk for the group, just in case there are a few of you out there who know that you might use this every now and then, but you're not quite sure exactly how the sausage is made and whatnot. So it's a ubiquitous material for objects conservators. We use it a lot for labeling collections, which might be how most people in the room are familiar with the product. When you label with it, it's often sold to you as B72 lacquer, and it's sold in a relatively dilute solution, and you put it down as your barrier coat on an object. You write the catalog number and then apply it as a top coat as well. For objects conservators and for other folks, maybe paleo prep and different jobs in the Natural History Museum, you might use it for repairing your collections. This is an example of a ceramic pot. So it works really well on ceramics, glass, and metal. And not only do we use it as an adhesive for repair work, but also as a coating on metals to help prevent against rust and corrosion. So we'll just talk about what is it. It's ethyl methacrylate copolymer solids. In the States, for a long time, we called it acryloid B72, but just recently, within the past few years, we've kind of joined the international community, and it's known as paraloid B72. But in this image, you can see I have an old stock of it that's still called acryloid B72. It does last a long time, so this, I imagine, I won't even get through the stock supply like during my career in the National Park Service. But it's these clear little pellets. And so what you need to do is dissolve them in a solvent to create a workable adhesive or a coating, basically whatever you need to use it for. And to make it, gathering your supplies first, you need to have your solids. You need to have your glass jar with a gasketed lid. I think this group dealing with fluid preserved specimens, you understand how important it is to have a good lid on your glass jar to prevent the solvents from just evaporating away. The solvents that work really well for B72, it's actually acetone is the best one, but it's also soluble in ethanol and then toluene and xylene, and among a couple others, but those are the best ones. And that's one reason why we like B72 so much. If we have a surface that we're working on or labeling that is sensitive to acetone, then you can make your B72 solution in xylene, which it most likely wouldn't be sensitive in, and use that, apply it in that way. So you can protect the surface so you don't cause further harm. B72, I forgot to say this on the other slide, so I'll say it now. It's also good. We like to use it because It has really good lasting properties. It's known to not yellow over time, although I have seen a couple stocks from really old ones that yellowed slightly. But it's relatively flexible compared to other acrylic resins. You can resolubilize it in the future using acetone or using these same solvents. It does lose a little bit of its reversibility, but it still is very good in that way. And that's one of the main tenets for us as conservators, is to try to have a material that is either reversible or retreatable, so that in the future, if something happens or if the mend fails or whatever the case may be, if you need to remove the B72, it's good, that it can be reversible so that you can easily take it off without causing further harm to the object. And then carrying on with the supplies, you need some cheesecloth, if you have that available, your hazards label to label the jar so that you know what it is, so you can go by OSHA standards, which is what we need to do in the United States. Have good ventilation, so you don't want to work in like a really enclosed space or like a closet or something like that, but you're only really going to be exposed to the acetone while you're pouring it out, so it's not necessarily like a huge amount. You're not going to reach your daily threshold limit for that solvent, but I know some people are particularly sensitive to acetone too, so if that's you, make sure you have a well-ventilated space. If you have a fume hood, use that. I even know some folks who have made their B72 outside, if that's available to you. And then also use some nitrile gloves so that you don't, if you do get the acetone on your skin, it won't dry it out, and you'll be just happier. Optional is a plastic pipette and a stirring stick. And I think you'd be pretty good to go. So I want to have a disclaimer at this moment that, it's almost like it's personal choice for objects conservators on how you make your B72. And I am someone who is not fussy about it. So I need to say that right now. You're a conservator, or if you are a conservator, you might be much more particular than I am. But I often find that when I'm making these solutions, it's when I'm working in the field and I don't have things like a stir plate or all of the materials at my disposal that I even listed. For example, I rarely use cheesecloth. So if you have any doubts, definitely talk to any conservator that you know, because I'm sure they'll be very happy to share with you how they make their B72, because I think everyone's a little bit particular about it. I'd recommend starting with a 20% solution. That's a pretty good one. It's fairly dilute, not super dilute, but it spreads really well, especially if you're using it for labeling. And you can just measure out weight by volume. So 20 grams of the pellets for 100 milliliters of acetone. You place it in one layer of the cheesecloth. You don't need multiple layers, just one. And then you can suspend it in the solvent and hold it into place using the lid. So you can see that that it's in the solvent, but it's not necessarily all the way in. And it'll just, the acetone will go ahead and react with the B72 and get it into solution. You can let it sit overnight for it to do its magic. If you do have a stir plate and a magnetic stir rod, you can put that in there, and that just helps the process. And then in the morning, I like to add a couple drops of ethanol, and I like to stir it to make sure everything has dissolved. The reason why I like to add ethanol is because acetone does evaporate so quickly, and adding that little bit of ethanol or something that has a slower evaporation rate will help your B72 retain those workable properties for longer. So it won't get as stringy, it won't dry out quite as quickly. But it doesn't, the reason why we don't just use ethanol is because it doesn't quite go into solution in ethanol as quickly and readily as it does in the acetone. Oh, and of course, label it with your hazards label as you see here. If it's too dilute, then you can add a few more of the solids. So just like a pinch of B72 pellets, throw that right in. You don't need to use a cheesecloth. And that's actually how I just usually make my B72. I measure out the pellets, I throw them in and let it sit overnight, and then in the morning stir it. So if you don't have a cheesecloth, that's what you can use. But yes, if you need your solution to be a little bit thicker, more viscous, you can add a few more solids, let it sit overnight, stir it, see what happens. Or if you do have a fume hood, you could let it take the lid off and let it sit under the running fume hood for a couple hours if you need it to be a little bit thicker in a shorter amount of time. And just keep testing it and see maybe with your stir stick if it is to the working consistency that you need. If it's too thick, then you can add a few drops of acetone. Don't be afraid to do that. And then stir it, allow that to dissolve, repeat as needed. If you need to add more acetone, you can let it sit overnight. And both of these techniques, they do indeed create a solution that is not 20%. But once again, in the work that I'm doing and in labeling, knowing the exact percentage of that B72 is not necessarily super important, because what you need is something that will work for you. And indeed, even if you make a perfect 20% solution, but you work with that bottle for a few months, then just having the lid off and on evaporates off some of the acetone, and you no longer have a 20% solution anyway. So some people, some other conservators might disagree with me on that. So that's my hot take. So hopefully that's all right. If it's too stringy or slimy or globby, sometimes that is because a lot of the acetone has evaporated off and it's just returning to its solid form. So you can add a little bit more acetone. That could help it, or go ahead and add a few more drops of ethanol. But sometimes it turns slimy because of the ethanol. And my colleagues and I have noticed this before. This image is from me working in Hawaii just a couple months ago. We had our solution of B72 and we needed to make a little bit more. So we used a batch of ethanol that had been at that park for probably many years and had taken on moisture from the air since it's so humid in Hawaii. And as soon as we did that, our B72 turned into this slimy solids that we could not use at all because B72 is not soluble in water. So if this happens to you, or if you have a batch that just continues to be stringy after you've added in different solvents, then don't stick with it, just discard it and start fresh, because sometimes there's really nothing that you can do to make it better. And I say if you're too lazy, but I should have that in quotation marks because I do not judge this at all. But you can go ahead and buy some. It is available, for those who don't know, at several different suppliers for museums and for conservation supplies. And that's sold at a 20 to 25% solution. And I actually like to use this too, even for my conservation work. Sometimes I go to parks and instead of me making my own container, I'll just use the labeling B72 that they already have on hand, which is really great since you can't fly with solvents in your suitcase or your supplies. And then if you're too overzealous and you have some drips, or if you need to remove a label that is incorrect or that is no longer legible, then you can do that with cotton swabs dampened with acetone. You'd want to make sure that the acetone isn't dripping off your cotton swabs, but it's enough, to really be able to apply it to the B72. And usually you want to have a few cotton swabs on hand so you can change them out as the acetone evaporates off. And on this example, it's a little gunky. You see all those black blobs. That's because this was an example I did for a labeling workshop, and the B72 hadn't fully cured yet. Not all of the solvent had evaporated off before I went in and made this picture of reversing it. So it really gummed up. So you can tell it wasn't quite ready. So you might have that experience if you do take it off before it's ready. So the solids you can buy from preservation and conservation material supply stores in North America. That's Talus Online, Gaylord, and University Products. The pre-made B72 you can also buy from Talus or from Museum Conservation Corporation, and the second capital M is intentional. And then the solvents you can certainly get. It's best, as we know, to have laboratory supply. But you can also, if you're in a pinch and you're out working in the field, it does work to use acetone from hardware stores. And then if you want any more resources on this, if you don't have a conservator to talk to, certainly email me, note the email in the bottom. And then there's several resources out there, mostly geared towards marking and labeling your collection. And that's where you'll probably find more of this information, including a National Park Service conservagram on the use of acrylic B72 lacquer for labeling museum objects. So hopefully this may have been a little bit helpful, maybe one tip that you didn't know before, but thanks for being here.
I wonder if you could recommend or disrecommend this B72 for repairing microscope slides that have broken, either just like in a clean shear or in different places on the slide and the cover slip. That can be messy and whatever.
Yeah, for sure. So B72 has been proven to be a really good adhesive for glass. And Steve Koob was a conservator before retirement at the Corning Museum of Glass, and spent his career kind of really studying B72, not only its use, but also its use on glass. And for glass repairs, what we would typically do is take painter's tape, the blue tape that's not very sticky, and that's how you can hold the slide into place, as long as you're not taping over something important. But you can cut a little tiny strip, tape the two sides in place, and then you can even make a dilute solution of the B72. You could try the 20%, but you might need to have something that's even lower than that, like 10%, and use a paintbrush and apply that on the break edge, and hopefully it'll just wick in through capillary action, and then let it sit for a while. Don't touch it for several hours. I would even wait and come back the next day to see if it has repaired. Yeah. Yeah, thanks.
Oh, I have a question. Did you say there was some materials that are sensitive to the B72 that among the
like painted surfaces? So you would definitely want to make sure that test your surface first before you put B72 on it, that it's not sensitive to acetone. So you can take a little tiny cotton swab with acetone on it and just do a little dot and make sure that it's not going to take away the surface.
And what was the alternative solvent?
Xylene and toluene, so non-polar solvents.
Thank you.
Need ventilation for that.
All righty, howdy. Can I still take 15 minutes for my talk? All right, I'm setting my timer. Boom, there we go. All right, howdy. My name is Dr. Ainsley Seago. I'm the new curator of bugs at the Carnegie Museum of Natural History. And I'm going to talk about my favorite topic today, which is bugs. So let's get going. I also just wanted to say hi. This is my first Spinach meeting ever. I've been in Australia for most of the last 12 to 15 years. And our museum has historically been represented here by our mammals curator, Sue, and the wonderful conservator, Gretchen Anderson, who's going to make a couple of cameos in this talk as well. Our invertebrate zoology bug people staff have not historically been here because they've been out in the field collecting. They've had a philosophy for a long time of collect first and curate later. And now I'm the curator, and it's my job to deal with all of the stuff they collected, but I also want to kind of try to raise our profile as a section among our professional peers in the entomology and the museum world. So hi, we exist, and I want to say a few words of introduction about our section. Invertebrate zoology has been part of the museum since its founding in 1895. Our two central facets have always been bugs and bones. The bones part is self-explanatory. We have our iconic Diplodocus. It's part of our logo. We have the holotype of Tyrannosaurus rex, but we wouldn't have any of that without the bugs, because the bug guys are the ones whose job it was to go procure those dinosaurs on behalf of Andrew Carnegie. William Jacob Holland, the distinguished gentleman with the mustachios, is the one whose job it was to go get the dinosaurs and bring them back to the museum and negotiate their purchase. So he dabbled in a lot of things. He did a little bit of paleontology, but most of all, he was a lepidopterist. He was obsessed with building an amazing giant Lepidoptera collection. And when he retired, he was replaced by the Russian emigre Andrei Avinov, who was also an extremely hardcore and obsessive lepidopterist. And I want to note, these guys were not the curators of invertebrate zoology. They were the directors of the entire museum. So we have 40 years of museum leadership being very, very highly focused on insects and acquiring insects. So as you might expect, this has left a mark on our collection. We have approximately 16 million pinned insect specimens. I say approximately because they've never been databased or counted in their entirety. And our collections are strongest in Lepidoptera, moths and butterflies, and thank God in Coleoptera, the beetles, which are the coolest and best insects, which is why I'm there. Now, with a museum that's still in its original building from 1895 in beautiful Pittsburgh, the Paris of Appalachia, we have a lot of interesting issues that are going to be familiar to those of you who work in historical buildings. Sometimes you have a little ground subsidence, you have a little settling, maybe a pit, a sinkhole opens up here or there, and you get a lot of cracks and crevices in your building, and bugs come inside. If the cracks are big enough, an entire coleopterist could come inside. That's me. My specialty is beetles. I work on beetle evolution, systematics, taxonomy, the evolution of insect iridescence. But a big part of my professional career during my time in Australia was doing biosecurity diagnostics, which is Australian for identifying all potential insect pests and invasive species at the second they cross your path so you can respond to them as quickly as possible. So that's the background that I was bringing into my position as a curator. So what I've been wanting to do when I started at the Carnegie Museum was sort of apply that diagnostic instinct to find out what pests we have, what insects do we have, I should say, I'm sorry, what uninvited non-specimen insects do we have in our museum, and what can we learn from them? So I've been working with Gretchen to not just monitor for insects in our insect traps, that's her job, but to identify all of the insects that are actually coming into our traps. And so this is something that I think Kelsey covered in her talk a little bit as well earlier today. We started out with the triangle traps or blunder traps, but I've also started making my own traps out of these beautiful yellow sticky traps from AlphaSense. These are traditionally used in agricultural IPM settings. They're really good for catching flying insects, but I love them because they're super sticky. They catch everything that even slightly touches them, and you can cut them up into strips and put them on your windowsills. Windowsills are great because a lot of insects are positively phototactic. They see the sunlight and they head towards the light, and then they get stuck in the window and they die there. So if you want to know what bugs are in your space, if you have windows, that's a really, really good place to put your sticky traps. You're also going to want some on the floors and the corners where your little debris feeders are crawling around, but windowsill traps, a lot of interesting stuff shows up there. And I'm going to show you kind of a rogues gallery of some of the stuff that we found. So Gretchen and I have been trying to build sort of a reference collection of the insects that are coming into the museum. And a central part of that with using these traps is being able to remove them from the traps without ripping them apart into tiny little shreds. So using my top secret desticifying technique, it's citrus oil solvent. You can take specimens right off. You can wash them off and then point mount them, pin them. You can even DNA barcode them. So it's actually really easy to take the bugs off and save them for future reference, which can be really helpful for pest control. So the results of this were unpleasant. We had about 30 traps sitting out in our windowsills. This is one of them. This is sort of, there's some expected insects and some not so expected insects. So these are some classic northeastern US insects. We have some cluster flies. They love to come into your building and have a million babies who all go get trapped on the windowsill. Haliomorphohalis, the brown marmorated stink bug, which again, this was public enemy #1 in Australia. You would have fire sirens over this, but it's just sort of part of life here in the US of A. Unsurprisingly, we got a lot of Harmoniax iridis. This is the invasive harlequin ladybug. They like to come in to buildings, especially because in the wild they overwinter in large light-colored granite outcrops. And it turns out when you finally wash 100 years of coal dust off the outside of your museum building, it turns into a large light-colored stone outcrop that's irresistible to this ladybug. Dermestids, sure.
some of us may have some dermestids. We had a diversity of dermestids that I was unprepared for. We had the classic insect collection pest Anthrenus. These guys are little pollen feeders in the wild, but boy, do they love to get into an insect collection and eat your dead insects. We also have Thylodrius, the odd beetle. Those guys are cool and weird, and I'm still a little bit excited every time I see them, even though I know they're a pest. But we also had the stored grain pest, Trogoderma, multiple species of that, as well as this generalist scavenger Megatoma. The weirdest thing that we found, though, was just in my section, invertebrate zoology, we had a large diversity of random forest beetles that aren't supposed to be in the building. Here's a selection of them here. We have carabids, click beetles, and lyodid beetles. This is a colivine lyodid. I did my PhD on these guys. They're supposed to be out in the wild eating fungus and decaying carrion, and I'm sure we don't have either of those things in my collection. So one of the questions we had is, where the heck are these guys coming from? If you look at the museum in aerial view, it turns out we're actually next to this gigantic gulch, this sort of wooded holler, as one might call it. And it looks like these insects are part of the sort of aerial plankton that are flying around in there, getting blown on the wind over, hitting our museum on the roof, on the walls, and then they are simply coming inside. So this is interesting. These aren't pests that are threatening our collection, but it is telling us where we might have some vulnerabilities in the outside of the building. Now, I don't want you guys to get the impression that invertebrate zoology is the only section in the museum that has weird bugs in it sometimes, weird unsanctioned bugs in it sometimes. So here's a couple of other little sort of vignettes from the Carnegie Museum. We have a lovely anthropology exhibit with some information on Native American cultures, including an exhibit on the central importance of corn. This title doesn't play exactly the same in Australia as maybe it does in North America, but actually it's ironically appropriate because you will say, we are rooted when you see how many tiny insects are coming out of your corn display. These are not museum pests. These are classic stored grain beetles, the Sylvanodora cephalus mercator, the granary weevil, Cytophilus. And it turns out these aren't, again, not something you really expect in a museum, but when you store grain in your anthropology exhibit, stored grain beetles are going to make an appearance. Another fun adventure in the humanities is the Carnegie International. This is about every 4 years. The art museum that's attached to our Natural History Museum mounts a massive international art show where they bring in artwork from all over the world to show off contemporary artists. And the idea of bringing in a bunch of stuff from all over the world all at once is what we call a biosecurity nightmare. And I got a cool email from my buddy Gretchen saying, I'm helping the art people, and there are some weird bugs coming out of the picture frames. And sure enough, there are termites coming out of the picture frames, as well as termite frass. And I'm lucky that I've been in Australia for some years, where Cryptotermes brevis and Schizotermes minor are some of our top biosecurity pests that we have to be on high alert for at all times. And we were able to determine that these are in fact tropical drywood termites, not from Pittsburgh, and therefore represent not an us problem, but somebody else's problem. The biggest surprise to me was that we didn't have as many insects emerging from this exhibit, which is a beautiful piece of installation art that includes various dried gourds connected by tubes and bamboo poles sitting on beds of dirt with a sprinkling of assorted seeds and beans. It's a beautiful art exhibition, but it's also something that would have been blowtorched at the border in Australia, and possibly you would have gone to jail. So I'm going to close today with a little story that I'd like to call the case of the library bees. Gretchen is very excited about this. So one morning in May last year, I walked into my office and there was a pile of bees on my desk. That's not unusual. It was a note from Gretchen and said, hey, we got carpenter bees in the Natural History Library. Carpenter bees are not unexpected in a museum of this age. You have a lot of old wood around door frames and window frames. Sure, you should get carpenter bees. That's normal. Let's put them in the reference collection. But I took a closer look. And as a matter of fact, these, sir, are no carpenter bees. The carpenter bees we get in the eastern U.S. belong to Xylocopa. This beautiful genus over here, they have a really shiny glabrous abdomen with just a little bit of peach fuzz at the basal abdominal tergites. Whereas if you look at, say, a classic bumble, here, Bombus impatiens. The queens are about the same size as a carpenter bee, but they have a very furry abdomen with a broad yellow stripe across the base. So let's go back and take a look at our alleged carpenter bees. We can see they have a dark fuzzy abdomen that is not shiny at all. They have a broad yellow stripe across the basal abdominal tergites. These are queen bumblebees, and they are ground nesters. They have come indoors looking for a place to build their home and have their babies, gotten stuck and couldn't get back out, and then they died in the library. And we don't need to spend a lot of money treating for carpenter bees because we don't have carpenter bees. They're bumblebees. They're not a museum pest. They're just bumbling their way in, and we just have to deal with that. And sure enough, a year later, almost to the exact day, I came back from some field work, and there was another pile of bees on my desk with a little note that says, "More library bees for Ainsley." I'm proud to announce that the Carnegie Museum is building the world's largest collection of library bees. I'm excited to see how far we can take this and just how many of these we're going to accumulate. But it also lets us know that maybe we need to take a look at the exterior of our building, because this is not a small insect, and I would really like to know exactly how they're getting in. So the lesson of my talk today that I'd like to leave you with is that you should identify the pests that you have in your museum if you possibly can. I can't volunteer this service for everybody, but you can take a picture and email it to me, and I'll tell you what you've got. And I will do that for as many people as I can, because I like learning about cool, weird bugs and what they're doing and who's got what where. So identifying your pests isn't just good biosecurity. It can teach you interesting things, and it can save you a lot of money on pest control. So thank you.
Morning. Thanks for that. Very lovely talk. A quick question about surveying for bugs coming into your museum. Have you ever looked in light fittings, and particularly sort of fluorescent light fittings, and seeing everything accumulated there? Often thought it would be a good place to start.
Oh, it totally would. Yeah, that's also an option. Those should certainly be something that you check periodically, because that's a real repository of dead bugs, which museum pest insects love to come and eat. So it's a great way to survey your diversity, but also a great way to, make sure you're not secretly attracting a huge colony of domestic beetles. So, all right, thanks.
Good morning. My name is Patricia Coorough Burke. I am from the Milwaukee Public Museum, and I am going to talk a little bit about the past decade in which I've been working with a collaborator at the Field Museum, Paul Mayer, digitizing our Paleozoic collections. This talk sort of came into my head because I'm now sort of looking at passing the torch to this next generation, all you young people out there who are going to be doing this in the future. So a decade of digitization. The first tip is to always say thank you to those that help you. And so I want to start with thanking IMLS, who has been a big supporter of our digitization projects, and remind you that they need help reviewing things. So if they ask you, definitely try and make time to review grant proposals for them. So our projects, and we divided them into 3 different parts, all take place. I just like this map, that's why we're doing this. But so the Field Museum is here at the tip of the Lake Michigan, and Milwaukee is, not everyone knows where Milwaukee is. It's 90 miles to the north, right on the lakeshore. So when we started our projects, we decided, well, we should do this. What should we start with? And we sit upon Silurian reef rock. And so we started with the Silurian Reef Digitization Program. And that was in 2012, our funding came through. So when you do these projects, think about who you're going to ask to fund, unless you are at a museum that has amazing funds and you can just do it on your own. But our timeline was, our first project started 2012, was a 3-year project. Then there was a little break to recover. Then 2017, we applied, and 2016, we applied and got another grant to do our Ordovician material. That we were lucky enough to land. That was in the middle of COVID, so that sent a few glitches in our way, but we came back in 2022 and are starting another project. So it didn't scare us away, but it did throw some little bumps in our road. And my first tip is to find a good group to work with. If you have people internally that you can work with on a project, or look around this room and see if there are collaborators that you can work with on a particular project, because pretty much all of us are alone in our departments, and it's hard. It's hard to make every single decision without having anybody to say, hey, what would you do? So think about having collaborators. It makes it a lot more fun. Second, think about your funding source, and you have to do that ahead of when you want to start, usually a year. And I'm saying that even though it always comes down to the last week before it's absolutely due, and then you're like, you drop everything else and you do just that. But if you were perfect, you would think about this, and you would think about who are you going to ask to fund you, and what kind of things they want to know, and what they want you to do to be funded. I also would advise, if you're just starting, to pick a project that isn't the hardest. For instance, I'm showing you a drawer in our collection, and this was our Silurian reef drawer, and this is the one we started with. It's one of the drawers. It is well curated. Almost all of the information is available, so when our kids came to do the data entry, it was fairly easy. Our next project, and here's a picture of a drawer from the Ordovician, there were scrawls on each rock with where it was collected. So start with the easiest, because when you jump in, you don't want the water to be boiling when you jump in. You want to, have it heat up slowly so you are tested. You don't realize how hard it is. The other thing that was pretty helpful, particularly when you're asking for funds, is to do a quick survey of what you have. That also helps you come up with an idea of how long it will take. Obviously, our Silurian collection was much easier than our Ordovician, and I built that into our time for how long each specimen would take. So you can do any granular level of survey, but just going in there and seeing what you have before you ask for money and help is very helpful. Then gather all of your materials, all of the materials that have any information about your specimens, and have somebody who can read cursive, obviously, because all of us have these old collections that have records that are in catalog books, but we also have, all the information on the labels. We have locality books. We even had locality cards and specimen cards. One of the nice things about, not nice things, there was really not anything nice about COVID, but one of the nice things about having scanned all of these things is I had access to them when we couldn't get into the building. So there was things that I could move the project ahead on during COVID because I had already scanned all these things. And then if you get funding and you are going to get students to come in, you're going to have to be ready for them. You want your taxonomic information as much as you can in your database, in your site information. All of these things you guys already have heard probably 100 times, but when somebody is paying for help, you want to be able to seize the day. So if you can, and sometimes you can't, try and be ready for them with all of this, preset information, so you don't get a lot of errors in your database by having people who aren't familiar with the terms adding things to it. Also, unless you really like having 800 calls a day, create a reference guide. So once you go through and you teach them how to add things, have something that can be sitting on their desk that they can look up and say, oh yeah, there's a screenshot. This is what I'm looking at. Otherwise, you're going to be sitting next to them for a week or two answering questions. And also for the data, for the photography, a file naming cheat sheet so they don't forget how to name the images. This just shows how I go through when I do the survey and get the majority of the taxonomy so that you can have it all already on the in the database. Oops, sorry about that. Our photography setup, part of it's actually, I found faster to have volunteers who stay for 5 or 10 years doing the photography. However, the students really need the break from data entry. So it improved the quality of data entry if they could do something else in between. And also they like to learn how to do the data, the photography. So we photographed both the fossils and the labels. The labels we just did with a little tablet, but the fossils we did nicer images. Let's see, one more thing to think about is how much mission creep you allow into your project. And MPM is planning to move to a new building. So there are some things that I was able to implement that will help in the move, but weren't really essential to the database project. And one of those was to give a storage location to every item that we database. And that did add time to the project. In addition, I added QR codes to all the labels. So each image has a QR code with the fossil in our database. Those things add time. So you have to decide, is this important enough to take away the time of, because you only get so many hours of student help. So it's up to each of you, but you have to think about it. One other great thing is to be able to recruit from your area universities. I have been able to get great students from all over Wisconsin and beyond. University of Wisconsin, UW-Milwaukee, Beloit College, La Crosse. These students love to come in. Some of them are still in the museum field, but it was a very important part of their career development. So if you can, get to know some professors at the local college and your university, you will get superb students. I also maintain my hardcore volunteers who are great particularly on the photography, because you don't have to switch in and out. I love students, but they're only there for a short time, and then they fly away to do their thing, and you are left with a new training process. So over the 10 years so far that we've been working on this, MPM has added over closer to 25,000 records. And if you follow those lines, you can sort of see there was a grant, big spike, then there was a break, then there was another grant, big spike. So these digitization projects really move in leaps if you can get funding and help. So it's worth trying, even though it's a lot of work to do the prep for a grant. So over 70% of the records I have in the database were put in by students working on one of these grants. So you can really make a great big difference if you put the effort in the front. And these are just some nice this is how I adapted for COVID, by taking photographs of the fossil and the image and then getting them on Google for the students. And of course, the photography is really at what everyone loves. So pretty fossils are hard to look away from. And my second to the last tip is make sure you write everything down and make a cheat sheet for yourself for future you so that you remember the students need access to this drive and that drive, and they have, because if you don't write it down, the first day they start, you will have to call IT and say, please, please, can you do this right now? And they don't like that. And lastly, and this is probably the most important thing, is to put a little fun in there, because these projects can get really, they can drag on their data, their hard work. So, take a field trip and look at the fossils in place, or go to the lakefront and have ice cream, whatever it is, put a little fun in, because otherwise you will dread these things. And that's all I have. If there's any questions from the 10 years of working on this. Yes, it's yes. The Institute of Museum and Library Services has several different lines. I believe ours was Museums for America was the area that we applied for. I think all three of them came from Museums for America, and it's a great program. They have deadlines. They're not like I am, NSF. So you will be up late for a couple nights doing it, but they're very helpful. Anyone else? Nope.
All right, just want to take a moment to thank our sponsors for the conference, and specifically Pestec, who's sponsoring this symposium. And I would like to announce our next speaker, Julia Colby, who will be talking about collection management tools from the Terrestrial Parasite Tracker grant.
Hi, good morning. Let's see, there we go. So I have some terrific project tools to share from a recent grant that we just wrapped up at the Milwaukee Public Museum and many other institutions. I've seen several people here that I know were part of this, so you can congratulate yourselves all on your hard work. The Terrestrial Parasite Tracker was an NSF-funded grant. It started in 2019. Like literally, I think 2 weeks before the world ended. This was one of the last things I did that year outside of my own house. And it is a fairly big institutional commitment, or a lot of institutions committed their time to this. So there are 24 primary data providers, 11 other collaborating institutions are supporting, and 7 other supporting institutions. And by 2022, we had 158 people who had been involved in this process in some way. And so it was a very, very large institutional footprint for many people. It's a large scope of animals. If we're talking about terrestrial parasites, that includes things like lice, fleas, ticks and mites, biting true bugs, and biting flies. And at many institutions, these things, there's no specialist. So you may have a little like abandoned legacy collection, but you almost certainly don't have somebody who is studying this full time, or maybe you do, and then you just have an enormous number of these things. And because often many institutions don't have a specialist on staff who's working in any of these groups, you may have these little tiny legacy collections, and the data is very scarce, and it's often not digitized, and it's sometimes not even in the queue to be digitized. And so this heat map here is the exodid or hard ticks that were available on SCAN in 2019. And it's not, there's some stuff on there, but it's not a lot, and it tends to be centered around major collections. Why parasites? I think most of us can understand, especially in this audience, that parasites are important in a lot of ways. They're important for human and animal health. They're ecologically important. They also are important as climate change happens. Things are expanding their ranges or changing their ranges, and understanding where those things exist in the first place is key to understanding how they are going to change as the climate warms. And you can also use this stuff for the basic stuff that we do digitization for, like, what is this? ID tools, taxonomy, that sort of stuff. And the objective of this grant was fairly robust, was about 1.2 million parasite records digitized was the goal, and then share this data with all the aggregators, and then also capture host parasite associations in GLOBI, which I'll talk about in a little bit. But this becomes important because often that parasite data comes with a host, like I caught it on whatever animal, and you can harvest that extended specimen data very easily from records like this. So the progress highlights as of, I think this is current for this year, there are 800,000 transcriptions and images produced. And so you can see here, this heat map has changed. So this is the original one we looked at. This was all the hard ticks, not very many records available. This is all the records that we created as part of this. And you can see that the heat map has gotten a lot hotter. And then this is now the total that's available. And many of these are georeferenced, so they have coordinates associated with them. And they also have this extra level of host parasite data. So it'll say what it came from or where it was collected or how it was collected, or there's other ecological information available. And so we actually exceeded our GLOBI goal. And again, I'll talk about GLOBI in just a second, but we added 794,000 records, association records in GLOBI. This was also a very heavy notes from nature transcription project. So we did 169,000 of those, which 40 expeditions. This was, for us especially, very useful. One of my lockdown projects was to sit there at my house scanning slides. And then we just shipped those out to Notes from Nature, and they got transcribed in about, 2 days, which was lovely, but also I spent 6 months doing it and it was over, and then I had to do it again, or I had to deal with it again. So we had a lot of these expeditions go very quickly and harvest really great data from those. So if all that lovely data and results was not enough, one of the things that something of any scale, any digitization project, but certainly something of this scale, produces is a lot of resources. And I think we can all sympathize with the idea of, you think about starting a project and it's great and you can see how it's going to go, but then you realize you sort of have to invent the wheel to get that project started. You need the taxonomy, you need the backbone, you need all of the procedures. And one of the end goals of this project when we started it was to produce things that other people could use, that we could share collaboratively within the grant, but then would be available after. And so I'm going to start talking about those right now. You'll notice it on all these slides. There's a little QR code, sometimes 2 QR codes, that will link you to everything that's on that slide if it's a downloadable thing. And if it doesn't work, or you want to email me, you can email me as well, and I will happily hook you up with those tools. One of the biggest products that was produced was taxonomy resources for this. Obviously, this is a project with a huge scope in terms of both invertebrate and vertebrate animals. So in terms of the taxa that we were sampling and then all of their hosts, you also need those to make a really strong association. And so this project produced taxonomic name lists for parasites, so fleas, ticks, mites, and lice, and then the vertebrate hosts, the birds and mammals. And there's multiple formats of these available. So if you want it, to be downloaded into your database and you use EMU or Specify, it's available for that, but it's also available for any research toolbox you may be using. And these are, you can't really see it on this screenshot here, but they have an expert's contact information and their version. So they'll tell you when the most recent updates were made and what those changes were. And the process for producing these is soon to be a major motion picture or paper. Sullivan et al. Was submitted this year to 2023. And this was also, I want to say, the work of a lot of people, many of whom are here. I know I've seen VJ running around at various meetings, but this was a lot of people's work to produce all of these enormous taxa lists. And so I think if you've dealt with a big taxa list, you know that it gets messy very quickly. And so we also, in order to produce those lists, had to have the cleaning tools. So there's ones available like OpenRefine and things like that, but we also created our cleaning scripts that are available at this QR code up here. for merging, cleaning, and matching existing lists. And again, you can use this to make your own list that's going in your database. You can use this to make a list that's going in your research toolbox. You can just make this list to, I don't know, wallpaper your bathroom with, whatever you want to do, it's there for you. And then Globy did not come out of this project. It was a pre-existing integrating website, but Globy essentially takes data interactions from open source data sets like aggregators, publications, anything like that, and then it links up those interactions. And provides them with DOIs of both the sources and the interaction itself. So here you can see, this is very tiny, but I've looked up this bat louse here, and you can see up here that you can sort of query on organism and 2 organisms. So you can say, what does the bat louse interact with, or what did the bats interact with? And then this is a drop-down menu. It got cut off here, but it interacts with, parasites by, pollinates. It's a whole list of possible options there. And then it will pull all the data it has, and it produces a search like this. So there is the bat louse, and then this is all of the publications or the database records that have those interactions, and you can pull the DOIs from them. And then if there's contrary information where so-and-so says, yes, those things interact, and so-and-so says, no, they identified it wrong, that contrary information would be included there as well, as long as it's citable. We produced educational tools and materials as part of this project. So as you can imagine from seeing the Globy, that's a fairly complex thing. And if you have 2 people doing it 2 different ways, you may end up with 2 completely different answers in terms of how they're interpreting that data. So we produced a data interpretation workshop. This is part of the Entomology Collections workshop course, but it's available as a carpentries package, I guess. And it's a reusable lesson plan that you can copy and modify and use in classrooms if you're teaching people how to do this, or for volunteers or interns, anybody that you have working in your collections. And you can modify it to do not just interactions, but just like data interpretation as well. And some project management and tracking tools. These are the ones that I tend to use the most often because I need to be able to report on how fast things are going and how well things are working. We have 3 here. There's this activity graph, which uses Python. If you input your current needs and your digitization goals, as well as images, slides, and transcriptions, it pops out this really nifty graph that tells you like how fast you're going and how you need to change in order to meet your goals, or if you're going to exceed your goals. And then this is very useful if you're talking to your admin and say, hey, we're going to do this, but if you give us 1 more person, it might actually finish on time. We also use these task and project trackers. We developed this for one of our technicians, actually developed this one in the back for our LepNet project, and it is phenomenal. Basically, everybody inputs their hours and their tasks in there, and then it auto calculates based on parameters you give it, and it'll give you things like how long each task takes and how much time you're spending on indirect task costs, and how much those things cost based on your budget, and then these pie charts auto update. And so this is a very useful way to gather data, not only for the project you're working on, but if you are going to write another grant to say, hey, we'd like to do this too, now you have hard data about how long all those projects take or how long that process takes. And that's very, very useful. So you don't have to just sit there and say, I don't know, maybe a minute, maybe 2 minutes, you actually have the data. And this is just daily activity. So it'll tell you, it's just a spreadsheet that will tell you and then auto sum what you did that day, how many images you produced, and then you can use it to track progress through there. And then there's workflow sharing. This is, again, the part that I dread the most about new projects is having to come up with the workflow and write the workflow and test the workflow. But I feel very strongly, as I think most of us do, that you really shouldn't have to improve the wheel. You can just modify it to work in your particular collections. So Bugflow has a collection of workflows available, and these are everything from like high concept digitization to like basic, like put the slide on the slide scanner, close the slide scanner. It's all of those things. And they're from real collection examples and protocols, some of which were developed for this collection, this project. Some of them are just pre-existing ones. And so it includes things like these, higher level big task clusters down to geolocate, and some like side scanning guides of here's how we did it, here's some tools, and they're very useful there's all sorts of things on here. So they're very useful. And if you have stuff that you would like to share this way, I am sure that they would love to hear from you. And that's what I have. So thank you very much. And I think there's a little bit of time for questions. Yeah. Okay.
Good morning. What is going on here? I haven't seen a regularly shoulder-mounted Cape buffalo look like that. Among other things, I am the World Taxidermy Championships competition chairman. It means I oversee judging, the rules, and of course the complaint department. Topic here is evaluating the institutional value and role of taxidermy mounts. Now the expression on that Cape buffalo is making sense. He's got a lion on his back and he knows it. The lion also has an expression of I've got a mouthful of Cape buffalo. Want to address the quality of mounts. And over the years, the Monte Albin Life Science Museum where I work has received a lot of different donations. And I will go and visit the donor, visit his trophy room, and, you know, assess it. And I walked into this one trophy room and there was a largest impala ram I had in my collection. It's from Kenya in East Africa back in the 60s. On the right, there's a snow leopard, I think. Now, is it better to have a mount like that if you're going to enter a, you know, snow leopard exhibit or a cats of the world exhibit? I think it's better than nothing. Some of the uses of taxidermy are for teaching. Here was an unfortunate pair of golden lion whoops, not that. Oh, that's the next slide coming up. Taxidermy can be used for exhibits and in a variety of ways. And here you see a sheep of the world exhibit at our museum. It was put on for about a year. And then there's a lion catching an impala in what we called the Africa room. So very visual, makes a wonderful display and eye-catching for visitors. Here's my golden lion marmoset pair. The female died in her nest box and wasn't discovered until after the male died a couple weeks later. They provided, and these were provided by the Hogle Zoo in Salt Lake City, and they worked together. I worked with a student. He got a comparative anatomy class project out of it, and the Bean Museum got a nice display. On the right, I like to use specimens, the real specimens, in conjunction with graphics arts and pictures, and otherwise it adds to a display. Another consideration of your taxidermy mounts at your museum or that might be donated to you is the historical considerations. I like to say, was this elk specimen collected by Theodore Roosevelt? Well, in my case, I have a lesser anteater that was collected around 1902, 1903 by a expedition that left the BYU Brigham Young Academy at the time and went down to Central America, and I know they went as far as Colombia from the data. Another special icon in Utah at the Hogle Zoo was the famous Shasta. Had a male African lion dad and a tiger mom, and she got to be well known, well publicized. And I remember seeing her back in I was pretty young, but back in the late 50s, and she didn't die until the 70s, but I was able to receive it from the zoo. Another consideration for taxidermy mounts would be their status in the wild. You know, are they extinct? Are they threatened, endangered? Here I've got a sloth bear from India. It was collected by an army officer there stationed in the 60s. And it's an interesting, fortunate specimen for us to have. The Philippine monkey-eating eagle was donated by the government of Philippines to another department on campus and ended up in the correct department, the Life Science Museum, and we're fortunate to have that. We've got extinct considerations along with the endangered and threatened, and here is a passenger pigeon exhibit, a couple of wood carvings, but an actual specimen. I'd like to say it wouldn't win any taxidermy competitions, but I'm not going to touch it and try to make it look better. It's extinct. I don't want to make it worse than it is, but it's a wonderful specimen to have. How to judge taxidermy mounts. This spotted skunk was an award winner at a taxidermy competition, but it would not have won anything if it could not do this in the wild. And they don't hold their handstand very long. I was fortunate to have one for a few months, a little youngster that found from the animal control people in someone's basement. But when I'd harass it, it would flip up with its hind end. Now it wouldn't stay up there, and that's kind of an artistic pose in a way, but it did win an award. Where I'm going with this presentation is talking about what makes a good mount, what is looked at. In judging taxidermy, we've got a score sheet that's made to help the judge look at the different items for a mount, and also to communicate with the competitor later on by having some drawings and things. There's the anatomical accuracy. How well does it portray the species? There's craftsmanship with how well is it put together? How strong are the antlers attached, or is the tail wire strong enough in the tail? And then the last thing that gives the judge and the competitor a fun ability to earn or lose points would be the artistic merit. So the ultimate goal is to recreate an animal. Whoops, missed the button. The ultimate goal is to recreate nature as it is. And this one's alive, but he's curious to come up and look in the camera. And it's also a super reference when mounting a bighorn sheep. Anatomical accuracy. Look at this, this panda recreation on the left. In the World Taxidermy Show, a recreation is just that, an animal that was once alive or is alive, but not using any of its parts. That panda was entered using black bear skins, obviously bleaching some of them, and that was part of his talent with it. But, and it won a top award in the recreations mammal. But look at the live panda on the right and compare the distance of the elbow to the knees. That panda, the living panda, has a pelvis that curves under, so which is not recreated in the recreation or duplicated in the recreation. look at the profiles of some of these mounts. That lion on the top left, I believe, is destined for the touch and feel room once I clip the sharp ends of the toenails or the claws. And you can see the bottom lion has better anatomical accuracy. That pike, that northern pike on the right, fish can't bend that way. It sure makes a nice sport trophy, you know, to put on your wall, but that's anatomically unable to do that unless you start breaking vertebrae. And then another comparison of the mallard ducks, kind of fun. The one on the left could be in a loaning collection or a touch and feel room. The middle one is, or the one on the mounted one on the right, the middle duck is a little bit better. That might be a candidate for display. But compare with a photo of a live duck and just look at the different grades of accuracy. Craftsmanship is how well the mounts are put together. And that one on the left, I believe there was 6, it could be 7, but that moose is attached by one steel rod, and the wolves are all attached to the moose or each other, and that earned the taxidermist, his last name's Harris. They call him Air Harris because of that. The avocet, you know, are the wings securely attached? That can be determined just by a simple touch. Artistic merit, difficulty, originality, the excitement of having an open mouth mount that duplicates nature. Look at that center bottom picture of a leopard. The taxidermist skinned the top of a cougar tongue and tanned it and then blended it into a epoxy tongue, so it perfectly duplicated the roughness of the tongue texture. I think personally, I think a moose or even a blue tit from Great Britain would be more difficult than mounting a black bear because of short hair, more muscles would show. So different degrees of difficulty. And I'm happy to be able to present here. I encourage you to attend my good friend, Steve Sullivan. He's giving a presentation at 4:30 today in Imperial B, I believe it is. And he will continue this with fixing and what's the word I'm looking for? Restoration. So thank you very much. And are there any questions?
Hi, thanks for the talk. I was curious about your thoughts about, I mean, I think a lot of us have seen how taxidermy mounts can affect people's emotions and be good for advocacy and sort of forwarding an argument for conservation or, I don't know, you know, bringing those kind of concerns to the front. Can you talk about accuracy as part of that, or?
Well, I think that's a very good question. And taxidermy, you know, it does bring in the public's view at a museum the real animal, and it does work towards teaching conservation. I don't want to brag, but I got a couple of blue ducks from New Zealand based on the educational value that would have at a museum that doesn't charge money. That was a part of it. And I believe Brigham Young University and the Church of Jesus Christ of Latter-day Saints, it has a nice relationship with the Maori chief at the time, was able to get things like that. And there it is in your face to teach and show the rubber end of the bill that helps it in foraging. I'm not sure if I hit your question right on, but it inspired me as a little boy to see mounted animals like the gorilla, the Cal Academy.
Thanks. I really enjoyed your talk. I was thinking about the touch and feel spaces that you were talking about where old taxidermy mounts go sometimes. And I've always been curious about the kind of health and safety concerns about those, because I know I'm scared of some old taxidermy because of all the chemicals that might be on it. And I'm wondering what you use and just what you think about it
Okay,
generally.
when I know how it was prepared in modern times after 1980, and I know it just went through the normal aluminum salt tans, we call it Lutan F in the taxidermy industry, and there's no danger there with chemicals like, of course, the age-old arsenic. And then I have to consider, are the kids going to get hung up on the claws? He hasn't made it to the touch and feel, but he also hasn't made it to deaccessioning either. And then, like I said, too, we use things for education outreaches, and the specimens that are involved there. I know some of my students have mounted them. I know of their preparation, prepared with borax, which, quote me, I believe is harmless. So does that answer your question? Good, thank you.
All right, well, thank you so much to all of our presenters for the Back to Basics Skillshare. We are going to cruise right into one talk from a general member session. So I'd like to invite Jia Xuan Lim to stage, who will be talking on insights and perspectives from the Li Kong Qian Natural History Museum. And thanks again to our diamond sponsors, Delta Designs Limited and Picture.
Okay, so hi everyone. We are just one presentation away from lunch, so I'll make this quick. I'll just dive right into it. So my name is Jia Xuan, is JX for short. I am a scientific officer from the Outreach and Education Unit of the Li Kong Qian Natural History Museum. We are located in the National University of Singapore. So if you look to the screen at the bottom right, that is how our building looks like. The building is pretty new. We are about 8 years old. In fact, we actually just celebrated our 8th anniversary in April. But the history of the collections in our museum traces all the way back to the 1800s in Singapore. And we have our origins rooted in the colonial era Raffles Library and Museum. So we are actually the only natural history museum in Singapore, and our collections is the largest in Southeast Asia. We do have a primary focus on research and education in Singapore and Southeast Asia specimens, but we do collaborate widely across museums and institutions around the world as well, in terms of research as well as digitization of our historical specimens. And we also hope that we can collaborate widely in terms of outreach and education as well. So we are very happy to be here at SPNHC to interact and connect with our counterparts in the education departments of other museums. So before I start talking about my work at the museum, I think it will be great for me to give you a little bit context on the general awareness of biodiversity in Singapore. So since the 1800s in Singapore, we've actually lost most of our forest cover, and a lot of our shores have been reclaimed as well. So what really remains in Singapore is a few patches of larger forests, but mainly just small pockets of nature spaces dotted around the island. But these spaces are actually quite accessible. They are quite well integrated into the housing estates and urban areas of Singapore because of the way that the city is built. So despite that, even though they are really accessible, there's very, very little interaction between the general Singapore population and their surroundings, and the awareness of biodiversity is generally quite low as well. So the role of us as education officers in the museum is really to try to bridge the connection between the people of Singapore as well as their immediate surroundings and the biodiversity by leveraging on our specimen collections that were amassed since the 1800s that are the very, very evidence of the history of environmental change in Singapore, as well as the history of the decline in our species. And these are really good storytellers as to what we have lost across the years and what we have left, what remains of our biodiversity. So I work in a really small team of just 5 people. That's our grand total head count. So 5 of us in the museum, we conduct almost all the education programs. In 2022, last year, we conducted about 230 education programs, reaching out to almost 11,000 participants. And these ranges from preschool level to university students, corporate professionals, educators, members of the general public, etc. Okay. And we are also happy to share that it's not really on the slides, but recently our museum have been ramping up efforts to increase our inclusivity events. So just very recently, we had our very first quiet hour in the museum where we reserved an hour on a Saturday morning, and we invited a group of art-loving, neurodivergent individuals to the museum to explore our space in a very quiet and comfortable environment. And we also provided specimens for these individuals to try their hand at illustrating the specimens. So our position in the museum, our position in the university actually places us in a good space to collaborate quite frequently with other departments in the university. So for example, we have collaborated with the Center of Nature-Based Climate Solutions in NUS to create or curate a program for geography teachers to teach them how to communicate climate science to their students. One of my personal favorite projects that we have done in the museum is called the Crime Scene Investigation Holiday Program, where we collaborated with the Forensic Science Department as well as the Physics Department of the university to create a program that teaches participants the basics of crime scene investigation. So what we did was we utilized the entomology collection of our museum to teach the basics of forensic entomology, among other techniques. So most of the bulk of the programs that we do at the museum are actually paid standard programs, paid gallery tours and workshops that are packed, or rather that correspond or complement the formal school syllabus in the Ministry of Education system. So these are all syllabus-based topics. For example, primary 6 students, which is the grade 6 equivalent, all of them have to learn adaptations of organisms in schools, and they would send cohorts of students to our museum because this is a place where they can interact directly with the specimens and learn about the adaptations. We also teach topics like evolution for secondary school students and junior colleges. So what we have is our programs are actually quite customizable. We often allow teachers to request for specific learning objectives to be incorporated in our programs, and this is for us to cater for all levels of learning. But what we also have is sponsored programs. So these are actually programs that are sponsored by our donors and provided free of charge to schools. So this is part of our commitment to make sure that our programs are accessible to as many as possible. So these are actually great for schools and school clubs or interest groups that don't really have a budget for learning journeys. So, and the nature of our sponsored programs is a little bit more exploratory rather than formal. So they are not necessarily packed to the school syllabus, and they learn a variety of topics. So we have things like marine protection, climate change, endangered species and conservation. So these are all about 3-hour workshops where the students will come to our museum, and they will go through a team gallery tour, and they will interact with our specimens to learn about these various topics. And it's really a good way for them to be exposed to topics that are not taught in school. And in these kind of programs, we also try to expose the students to different kinds of conservation-related or biodiversity-related career pathways as well. So in marine protection programs, we talk about the role of marine scientists. And then in endangered species and conservation program, we talk about the role of illegal wildlife trade enforcement officers. So this is to give exposure to the students on the different kinds of career paths that they can take on in the future. So we take our content outdoors as well. We do conduct programs at the intertidal shores, the mangroves, and the forests of Singapore. And this is really building on the wonderful work of our scientists who really has described so many of the species in Singapore. And what we do is we teach the students in a digestible manner about the species that you can find in Singapore and ecology as well as basic fieldwork techniques. So if I could direct you to the very first photo on your left, this is actually a photo taken from our annual the annual camp called Youth Environment Camp. This is a camp that is organized for ASEAN countries, ASEAN meaning Association for Southeast Asian Nations. So we have students flying in from Malaysia, Indonesia, Vietnam, Myanmar, and the museum is actually a partner of this program, and these students will actually spend a week in Singapore to learn about the biodiversity and the ecology in our spaces. So I'm also very fortunate to be working with a lot of creative colleagues at the museum. For many years, we have been thinking quite hard about how we can make conservation, teach conservation in a more enjoyable and hopeful manner rather than a doom and gloom topic. So instead of, just pointing to the specimens of the museum and telling them that, oh, we lost this number of species across this number of years and state the reasons of us losing the species, we wanted to use games to complement or to supplement what they learned from the specimens in the museum. So my unit has come up with 2 games or biodiversity theme games. One of it is on climate change. The other one is on food webs in marine ecosystems. So for these 2 games, they're actually cards that communicate the impacts of changing environments, but there are also action cards that communicate the actionable solutions that could potentially change the tide of the game, which mirrors the effect of policies as well as initiatives implemented in the country to mitigate impacts of destructive human activities. So for the climate change game in particular, we plan it to be in local context. So it's a Singapore climate change game. And when students participate in the game, they learn about the different types of ground-up initiatives and nationwide government policies that are implemented to conserve the nature. So our virtual programs are actually developed during the pandemic period. So all of our virtual programs are not pre-recorded because we wanted the aspect of interacting live with our audience. And we do have paid virtual programs for schools and free virtual programs for anyone. So under our free virtual programs, there's 2 categories. One of it is called webinars, whereby we have our museum associates or research associates, our museum officers, showcase their findings from their current latest research project to fellow scientists around the world and interested individuals. But we also have another kind of category called web talks, or it's really just casual chit-chat sessions between ourselves and environmental champions, non-government organizations, other researchers, and it's a little more casual and free of scientific jargon. So anyone who is interested, a casual nature lover, or just primary school, secondary school students would be able to enjoy them as well. So of course, with the pandemic, we have also done lectures online. So all of our free web talks are still available on our websites, and all of the virtual programs that we have developed for schools are also still in the offerings. We made it permanent to make it accessible to all. So because we are just a team of 5 people, there's a limit to how many people we can reach out through our programs. If only we could split ourselves into 2 or 3 and then do programs concurrently, but we can't. But what we can do is we realize that when we offer training programs for educators, for student groups that are interested in having their own nature walks, for example, we can actually help these people to train their own target audience as well. Okay, so we have gone through, or we have planned quite a number of training programs for school educators and for student groups and even corporate professionals. And we equip them with basic guiding tips and biodiversity knowledge so that they can curate their own programs for their own groups of target audience. So the most exciting part of my job is planning school holiday programs. In Singapore, there are 2 major holidays in June and in December. And every year we would plan a holiday program of a different theme for members of the public. So the top one, to your left, that is actually the crime scene investigation holiday program that we did. So we did a mock crime scene in the gallery of the museum, and we invited participants to come and check out the space and to look for clues to solve the case. At the bottom, this one is really interesting. The one in the middle, the photo. So this is actually our workshop on various techniques to document nature in the past and in the present. So this girl in the photo, she's actually painting a fish. And this is actually based on the traditional method of documenting fish by Japanese fishermen. This is called gyotaku printing. So in the past in Japan, the fishermen, they would fish out the fish and they would use a non-toxic paint called sumi ink. And then they will paint it across the fish and they will print a rice paper over it. And then they wash the fish and they can sell the fish still. So that allows them to document the size of the fishes. And we did the same, except we used acrylic paint. So for this workshop, the students were able to, we provided them with like a plain bag, and they were able to paint one of our specimens, and they would print the fish over, and it transfers the paint to the tote bag, and they have a souvenir of our specimen or print of our specimen to bring home after that. So we have also done collection tours in our museum, which is quite rare for us. Our collection space is really small and quite narrow. So we were initially quite hesitant to roll out this program because it disrupts the work of the curators working in the museum. But we have done it a few times now, not too often. And we think that it's a really good way for the participants and the general members of the public to know that the museum is not just a gallery. It's a lot about the work that goes behind the museum and the science research that we do as well. So going back to the volunteers, because in Singapore, for students to be engaged in learning journeys, the instructors have to be registered with the ministry. So our volunteers, they do not do school programs. All the school programs are conducted by us, but instead they are really instrumental in helping us with our abridged version of gallery tours that are offered to visitors on weekends. They also help us with our corporate social responsibility tours. So I'm just gonna end off by showing you this part of our webpage. We have 2 virtual tours of our museum on our webpage. I highly encourage everyone who has not visited our museum before to check them out. Thank you so much.
Okay, well, I'll give a slightly longer lead in here then. So wanted to share some of the experiences we've had around our digitization project. We are working with Rediscovery at the Science Museum in Minnesota. Maybe some other folks are doing the same. Maybe you run into some of these same kinds of problems regardless of what you're doing as you go through digitization projects as well. So I want to share some of those experiences there in hopes that they might help some folks out there, as well as just kind of maybe even get a little catharsis of someone else going through the same thing you are too. It is a little kind of technical, so I threw in a lot of fun photos of fossils to make it a little more interesting here. So let's dive in. So this is all centered on part of our paleontology collection at the Science Museum that we call the Wanagan Creek Collection. This is from an awesome fossil site that's about 60 million years old. Not only does it have tons of my absolute favorite group of animals of all kinds, crocodilians. So this is a beautiful skull here. Some of these are preserved in amazing details, a lot of them three-dimensional, but it also includes tons of other fun things, including this is a very nice skull of an early snapping turtle. We get primates as well as lots of other early mammals. We get birds, we get even leaf fossils. We actually have a large fossil leaf collection from the same spot here. We get, I got to throw in another crocodilian, Wanagatusuchus, this early alligator relative, which actually is going to be in the specimen spotlight session later today. And dragonfly wing, we get insect fossils here. These are exceptionally rare. And we even get fossil fungus. So we are looking at really a great snapshot of the ecosystem about 60 million years ago from this one spot in North Dakota that has been amazingly and lovingly collected over many, many years and is now home at the Science Museum of Minnesota. So to give it just a smidge more scientific context though, what we're talking about when we're talking about the big mass extinction event that happened relatively soon before this, a lot of what we know about the end times of the age of the dinosaurs is the Hell Creek Formation. So that's what you're looking at in in gray here, strewn across the Dakotas and Montana and Wyoming. And that kind of sits right there at the right up to that mass extinction event. So we have a lot of great samples from that in a lot of museums all over the place. When you flip around to the other side, it's not quite as comprehensive. And when you sit this fossil site, you're looking at a very similar geographic place as well as just a little bit kind of later geologically speaking. So it gives us a great opportunity to learn from this ecosystem about the recovery phase, about what life was like after that mass extinction event. So you've got the doom and gloom in the bottom there, and then we've got a Wanagan recreation there where things look so serene and wonderful. So it really gives us a great chance to learn a lot from this, but really a lot of the records of this is not that well known. That a handful of publications, but nowhere near the vastness of the collection is out there. So that's where we're trying to do this digitization effort. Just a little context, we're, as I was saying in the beginning, on Rediscovery. We split our three main collections, paleontology, anthropology, and biology, as separate subsets within our kind of umbrella within Rediscovery. The collection was built up between 1970 and 1996. And this was the status of the collection data, such as it was when I came in to start at the Science Museum in 2018. So I'm guessing a lot of us have run into the same situation where this is your data. There it is, got to go get it. If you want to know what we actually have in that collection, you either got to start opening drawers or you got to literally be standing in front of that card catalog. Otherwise, you're not going to know what's going on. So if you're a researcher in Switzerland, you're not going to have a great comprehensive view on what there is. However, that was kind of the norm for a very long time. So I don't want to denigrate it too much. This was largely built up by my predecessor, Bruce Erickson, who was at the Science Museum for over 50 years and built up this and many other collections. So in many, many cases, great records alongside everything there. So that information is there. We just need to make it accessible. Thank you very much to IMLS for funding our ability to do this. Took on a 2-year project here to start tackling all this and use this actually as our pilot really to digitize the entire fossil collection at the Science Museum. And of course, you kind of put together a workflow when you're putting in these proposals, fully realizing you're going to be revising that pretty shortly after you get started. That's exactly what happened. Some of that kind of hung around, but a lot of it didn't. So some of the initial things that we had to adjust about that workflow, I'm going to share with you, and are probably some of the same kinds of things you might be running into as well. First was kind of creating within Rediscovery a place for us to put our generated unique identifiers, or GUIDs. There's a few different sources you can use for these. We use GUIDgenerator.com. So that means that this lovely little mammal tooth and femur here can now have a unique number or unique code that will go with it as we ultimately push towards larger internet aggregators such as IDicBio and GBEF. Another thing we ran into, we had a little bit of a bias in our latitude, longitude, where everything was basically de facto into the Northwest Hemisphere. To be fair, that is the wide majority of our actual fossil collection is from that hemisphere, but that is not the entire world, as it turns out. We do have some stuff outside of the Northwest Hemisphere. So not only do you want to kind of convert this into something like 47103, but instead to -103 to be more in line with the rest of the world. Another one is having a very useful spot for internal notes. So as we're going through each one of the specimens here, this is a great opportunity to assess, if it needs identification or preparation or anything like that. So this unseeming box of little bits and bobs is from a champsosaur. And if you don't know what champsosaurs are, oh man, I could gush about them for a while because they're these adorable crocodilian-like things. They're actually not even crocs at all. They're this totally weird group of reptiles. Absolutely love them. Their vertebrae are unlike anything else, so we know it's definitely a champsosaur. But this gives us a chance to put a note with it with something like needs ID label, prep and rehousing. And oh, by the way, there's a fish in there too. So this gives us a good chance to be like, oh yeah, maybe we should pull that out and give it its own kind of unique identifier as well, and create a different number for this that's unique to that. And just in case you didn't already spy it, there's your little fish vertebra right there. Available resources, another field where it gives us a chance to put anything else that might be affiliated with it. So this is namely in the form of digital assets. So we've been scanning a lot of the things tied to this collection, but of course we've been taking lots of pictures. This is a lovely shell of a early snapping turtle, Protocolydra. And this one actually has field notes directly associated with it. So we actually have kind of the sketches that were done in situ as they're excavating it out. So we want to affiliate that with the record, as well as, of course, accession records. And it can be all kinds of other things. So we're starting to get things like CT data and stuff that we want to make sure that anyone pulling up this record is aware that those also exist for them. Another one is creating a spot for other locality information. This sounds like just kind of a vague catch-all in sort of a way it is. But where it comes in for us very handy is just distinctions geologically between upper and lower levels. So that way we can easily pull together, say, all the stuff that came out of the upper level. Another big one that we've added in is quarry square. So Wanigan was quarried out with good, meter squares. A number of our other sites are like that. So it becomes a really handy way for us to pull together, say, anything that else might have been found alongside this garfish. And if you don't know what those look like, they're totally adorable fish. Look at that. So we can easily pull together everything from H6, and we can see if we can find any more of that gar or what it was directly associated with quickly and easily. So it's been a really handy thing for us, and will be as we move into other parts of our collection. Another one is to actually just go ahead and create a spot for the card catalog itself. So ultimately thinking we're going to be printing new labels for a ton of these things. So having a spot for just what the taxon and element of the card catalog are going to be was very helpful for us to easily export that. That also allows us to kind of grade out sort of taxonomically what we want to call the thing. So if you kind of default to species every time, there's a lot of times you don't know what the species is, and you don't want just just unknown on your card when you know it's like a crocodile, but you don't necessarily know which crocodile. So this way we can put what's the most useful taxonomic name to put with that, as well as the element that's supposed to be there. So this is a mandible or lower jaw of the early snapping turtle. Now, really, ultimately, the goal is to shift all of this into a large internet aggregator. And part of how we've been attacking that is by the great our help from VertNet. If you're not familiar, this is an integrated publishing toolkit. This has had some funding behind it in the past, but now it's a little bit more on the volunteer basis, and but we're still very appreciative of it. And this ultimately gets to iDigBio and then to GBEF. We can export that with an easy little web-ready tool like this lovely little bird bone. And comes in the form of a spreadsheet that gives us a good chance to just pull out whole columns like those internal notes, or if there were any sensitive data. And we can, and as a result of this, we've run into a couple other little issues. Things like date formatting. So like this beautiful crocodile skull and jaw we know was pulled out in July 29th, 1975. That's an easy thing to convert. However, not everything got all that love and attention. So this unseeming chunk of turtle shell did not get that kind of attention, and it's collected. Now, we could just leave this as unknown, but that's not actually true because we know the work was done between 1970 and 1996. So we are actually putting that range in there because it's not all of the enormity of time. It's within those 26-ish years. So this is going to appear as verbatim text. These do get kind of verified, the taxonomic names. There's a couple different resources where this is done. Basically, it's really trying to make sure these things are actually valid names as well as spelled correctly. So this is just one example of how that can happen. When there are conflicts, they can be resolved either by providing a reference, which is what we did in the case of these, which are trace fossils. I'll get into that in just a second because that's a whole sticky thing in itself. Correcting internally, especially like if it's a simple mistake, or you can override that and present it as verbatim text. We also have these beautiful trace fossils from there as well, including these crocodile tracks and effectively horseshoe crab tracks. And these are trace fossils, right? So they're not actually tied to any direct hierarchy within the taxonomic system. So how do you deal with that? So we've been kind of going these higher level parts that don't actually tie in with the regular taxonomy, but still providing some information. It's still out there, it's still searchable. These are even holotypes, so it's extra important to get those out there. But this is kind of a larger thing that we're ultimately going to have to deal with, how we deal with ichneid fossils or trace fossils in these big data sets. So the work is continuing. Ultimately, we will have our first data push on iDigBio hopefully quite soon, and hopefully more to come, and then on to GBEF so that everyone can know about this awesome fossil collection that we're working with at the Science Museum of Minnesota. Much thanks, of course, to IMLS and Charlie Iverson. I'll give him a direct shout out. Our registrar honestly should be an author on this. Lots of great volunteers at the Science Museum. And quick plug for Specimen Spotlight at 3:40. You can check out a lot more within 5 minutes on the early alligator Wanaganosuchus. I will stop right there. Thank you. It looks like we got just a couple minutes for questions. If anybody's got it. If not, I'm going to gush about crocodiles the whole time. So go ahead.
Since no one asking a question, I'll ask. Going through maybe some of I saw your filing cabinet, maybe there's folders of information. Are you coming across any stratigraphic data that might be associated with any of these specimens? And how are you maybe handling that in your new database system? We struggle with that. I'm just from San Diego. We struggle with what field is that going? Is it a remarks field or some sort of standard field that we want to develop for stratigraphic position?
Yeah, so of course we have that quite a bit. In terms of the Wanagan Creek, a lot of this is essentially coming from one geologic unit, so everything kind of has that. That's where kind of that like other locality information has come in to put in upper or lower level and quarry scores. And so we've added a few other kind of things that are a little more specific to stratigraphic context, but trying to capture as much of that as we can with each of those records. So for sure, that's very top of mind. Anything else? Okay. Oh, and I also have a 3D print of that Wanaganosuchus skull, so come check it out. Thank you.
All right. Our next speaker is a virtual. And do I have to click it again? I think I do.
So, good afternoon. My name is Cristabel Evelia Alvarado Perez. Today, we are going to present the strategic management of digital transformation in natural history museums, the key role of collection. In our team are Dr. Eulalia García Franquesa from Museo de Ciencias Naturales de Barcelona y Dr. Joan Antoni Pastor Collado from la Universidad Politécnica de Cataluña. The presentation is divided into 4 parts: an introduction, main challenges for natural history museums in digital transformation, the applied research project at the Museo de Ciencias Naturales de Barcelona, and conclusions. So let's start with an introduction. What is digital transformation? Let's us define it. Digital transformation can be defined as an evolutionary process that uses digital capabilities and technologies to enable business models, customer experience, and operational processes to create value. It is a complex process that involves redesigning legacy systems, processes, and organizational culture to acquire new skills and organizational agility. Therefore, digital transformation is a major challenge for organizations today. Looking at the diagram, both digital transformation and natural history collections cut across all museum functions. As we explained earlier, digital skills and technologies enable value to be created, improve operational processes, customer experience, and business models. But these changes have also changed the way information in collections is accessed and used, and the format in which it is required. It has also changed the way research is done today, as data associated with the specimen is required from internet portals. Natural history collections have therefore changed their place in today's society, and we need to maintain their relevance in the 21st century. In addition, this transformation has created virtual collections, which, like physical collections, require care and management. As a result, the tasks, responsibilities, and roles of collection managers and curators have changed. What is the relation between digitization, digitalization, and digital transformation? Basically, it is a process in which a physical object is first converted into a digital form or data. This newly available data causes a change in an organizational process, and after many processes within the organization have changed, the transformation is complete in 3 dimensions: people, process, and technologies. In our case, for example, this transformation creates a digital museum. A digital museum is a museum that uses information systems and information technologies to digitally represent the functions of a traditional physical museum and to share the resources of the curricular objects it holds on the internet. What are the main challenges for natural history museums? As non-profit organizations, we need to maintain the link with our publics and audience to serve society. So we need to justify our existence in order to obtain the necessary funding. And we need to remain relevant in today's society by providing easy access to the collections through the internet. I mean that we need to offer data usability. Separate studies have been carried out on digitizations in museums, and one of them was done by the Network of European Museum Organizations. They made a survey in different museums in Europe, and 75% of the museums answered that the main obstacle for digitization is insufficient resources, money, and insufficient time of staff. Regardless the percentage of collection digitized, natural history museums have the slowest average at 15%. The size of the collection and the variety and type of objects, because we have complex 3D objects, made attacks even more difficult. Natural history museums need appropriate technology and additional resources to digitize their collections. The Museum Sector Alliance, MUSA, has also studied digital transformation within museums and identified the main barriers: lack of investment in digitizing collections, limited investment in information systems and information technology infrastructure, gaps in organizational structure, inadequate training programs, lack of digital literacy, and lack of strategy or planning. Clear guidelines are needed to address digital challenges. So as a result, they suggest that museums adopt a strategic management approach to managing and embedding their digitization activities. Today, virtual digital natural history collections are a must. On the one hand, we need to open up collections and knowledge to new audiences in order to remain relevant. We want to increase the number of requests for collections. On the other hand, the demand of collections, the demand for collection data in digital format is increasing. However, these virtual collections require careful curation and management to ensure their long-term currency and value. Collection managers and curators are therefore caught in the middle of this context of change. As a result, we need to plan digitization projects and deal with complex decisions such as resources, methods, standards, digitization teams, interoperability, and legal issues. In addition, making process more efficient and effective to reduce costs, it is also an important aspect of decision making. This is why we are talking about digital transformation. This context of needs requires the improvement and innovation of people, process, systems, and technologies within our collections and museums. Now let's talk about the applied research inside the Museo de Ciencias Naturales de Barcelona. El Museo de Ciencias Naturales de Barcelona has experienced this context of change. Within the institution, we have people who are very committed to innovation, such as our collection manager, Eulalia Garcia Franquesa, or various curators like Frances Uribe, who have worked to make the collection's data accessible. For this reason, they have created a portal where they share different data on the internet. The portal is named BioExplora. They share from 3D models to scientific information on different specimens or historical collections. They also have to work on the adaptation of their databases, which are diverse, as Pangea, Specify 7, Museum Plus. They have submitted data to YGIF, and they are part also of the DISCO project. However, as they do not have their own IT system department, various alternatives were proposed to improve these processes of digital transformation inside the institution. There, in various discussions with the Information Systems faculty of the Universidad Politécnica de Catalunya, an industrial doctorate project was proposed and approved, co-founded by the Generalitat de Catalunya within the industrial doctorate plan. This project has already initiated and started on July 2021. The project, in the format of a doctoral thesis, aims to organize the problems, questions, and methods related to this topic. In order to design a method for the strategic planning of the digital transformation of natural history museums, and as a result, the first digital transformation plans for the collections area. We have selected a research method, a constructive research approach, because it is a qualitative engineering study using a pragmatic design science research approach. What is the meaning of that? Design science research is a research method that fixes with the creation of an artifact, an artificial artifact, the construction of an artifact. In our case, we have selected the Heaven model to contextualize design science research. In this model, we have 3 different cycles: the relevance cycle, the rigor cycle, and the design cycle. In the relevance cycle, we have the requirements and the field testing. In our case, the environment is about the natural history museums and the Museo de Ciencias Naturales de Barcelona, which has the museum domains, the people, the culture, the organizational systems and structure, the technical systems, the practical problems, opportunities. This is the area in which the practice and the practical relevance happens. But on the other hand, we have the rigor cycle. In our case, the scientific foundations is done by the Universitat Politécnica de Catalunya, and the literature review, the theories and methods that already are, our professional experience and expertise, the theoretical problem, in our case, the lack of methods for natural history museums, regardless the digital transformation initiative, and the research outcomes. In that case, is the theory and pragmatic validity part. And the design science research is in the middle, and we are designing by building an artifact and process and evaluate it in the relevance part and the scientific and rigor cycle part. We already have made the meta design, which is the roadmap for the research. In our case, we have 5 steps: objective 1 to objective 5, which is the problem awareness, the suggestion, the development of the artifact, the method, evaluation, and conclusion. Inside the research, we have 2 main studies of museum sector: a benchmark of 16 reference natural history museums, as the Natural History Museum of London, the Natural History Museum of Berlin, the Smithsonian. And this study aims to understand deeply the context of natural history museums. Also, we are reviewing the digital innovations published in Museum and the Web proceedings. Museum and the Web is the biggest and most important congress regardless digital innovations in the cultural heritage sector. And we are reviewing if the method could be extensible to different sizes and other disciplines. So to conclude, the strategic digital transformation planning is a decision-making tool to maximize opportunities and minimize risks. We are doing a pioneering approach for natural history museums and their collections, thanks to the adding of theories and methods of information systems and management areas. And we are doing the first version of digital transformation plan for the collection area of the Museo de Ciencias Naturales de Barcelona. So thank you very much. If you have any question, you can grab me and we will answer you. So bye-bye.
Right. I would also say that if you had any questions, you can contact through the Oxford Abstracts platform, and that'll work really well. So our next speaker.
Good afternoon, everyone. I'm Maarten Trekels from Messe Botanic Garden, and I will briefly present you the Disco Flanders project and what our plans are for the future for Disco Flanders. That being said, Disco Flanders is not only me. I'm coordinating this project, but it's actually, I'm just a guy that likes to talk a lot. There is a lot of people in the background that are doing all the hard work and that really can deserve the credit for all the things that's happening in Disco Flanders. What is Disco Flanders? Before we go to the future, let's see where we are today. Disco Flanders is within the Disco project, one of the projects that is funded by a local agency, a local funding agency, to get closer to the Disco infrastructure. Disco stands for Distributed System of Scientific Collections. It's a Flemish project, so Flanders, that's the upper half of Belgium, consisting of the Flemish universities. So there are a lot of universities holding research collections or are holding other collections that they are not aware of. We have some research institutes, but also these research institutes not necessarily have collections in their DNA. They do hold the collections, but that's not their main purpose. We have us as Massive Botanic Garden who do have collections at heart, but we have one particular partner also in Disco Flanders, which is the Belgian Association of Botanic Gardens and Arboreta. So we have a big collection of living plants, which is part of the Disco Flanders project. On top of that, on the bottom side, we also have a few associated partners, which are the big federal collections, the Natural History Museum in Brussels and the Royal Museum for Central Africa, and two French-speaking universities. Within this project, we are working around 4 key topics. First, we want to look what is in our collections and assess in what kind of state they are. Then we want to focus on some best practices and guidelines. This is how do we deal with our collections. There's a big pillar around infrastructure, because infrastructure is really a need. And infrastructure is broad. It's not only software, it's not only hardware, it's also people. And then the last pillar is about data usage and sharing. All of that is surrounded by a help desk. This help desk is not only internal to the project, also other external people can just send a question to our help desk and we will try to help you further if we can. What's the big difficulty within this large variety of institutions which is in our project? That's a large variety of institutions means a large variety of collections. They go from preserved collections to living collections to seed banks, maybe even library are part of these collections. So basically, huge diversity. It goes from biology to paleontology to mineralogy. There are very well curated collections. There are collections that are curated by at maximum a volunteer, or there are just non-curated collections within these institutions. Not every institution has a staff availability which is needed to take good care of these collections. So you can feel that there are some issues that are around all these different kind of collections. How do we want to look at the future with these collections? Where do we want to go with this? And first of all, we need to know our collections. And we all like to pretend that we know our collections, but actually, if you go in detail and go and look into your cupboards, do you really know your collections? Maybe, maybe not. This first step, try to know what is inside your collections. Then you have to figure out what are the strengths and weaknesses of your collections. Strengths and weaknesses of your collections, maybe you hold very specific things, or you have one very specific expertise, or you have one specific set of people that have expertise in these collections. People, I will again stress this, we have to empower people within these collections, make sure that their knowledge is used and used in the most optimal way. And then invest in infrastructure and collaboration. And in between my quotes, there is people again. And it's not because they're less important, it's just because they are really important. And infrastructure includes those people. So first, know your collections. So we started in Disco Flanders on getting an inventory on all our collections. So we just reused something which was done already in another European project, which is Synthesis Plus, which basically is just a spreadsheet that everyone has to fill out and say, oh, I have X number of specimens of this. And they had to go through all their collections to see what is there and whether they are digitized or non-digitized. At least then we have a starting point to look on how do we further develop our collections. And you can see roughly with our first estimates, we have 6 million specimens within Flanders, of which a bit like over 4 million are digitized. There is a big emphasis on plants because our herbarium is already having 4 million of those specimens. But there are a lot of other things that we discovered. like a collection of 500,000 fish bones that we actually were not aware that they were there. Well, the institute was maybe aware, or the curator of that collection was aware of this collection, but nobody else was aware of this one. And it's a significant collection. We also get kind of an idea on what kind of condition they are, these collections are, and in what kind of storage type they are all. So we try to make this a dynamic dashboard, so we will repeat the exercise after a while, because we're still discovering other collections. And we try to map all data to already an immersion data standard, Latimer Core, so that if anyone ever starts reading Latimer Core data, the data is ready to be ingested. Weaknesses and strength. Again, we looked at synthesis and looked at the synthesis collection self-assessment tool. We modified it a little bit because, of course, we have these living plant collections which are not considered in the first place within this scope, but we do want to include them. So we slightly modified this survey and tried to reflect on the strategy that each institute had. Can we make sure that all these institutes that also have collections at least have their collections in their mission statement? If that's the first entrance, if we can get that in the mission statement, at least someone will look at them. Reflect on how many people are in these collections. How are they managed? Are there sufficient people to manage these collections? And do they have the infrastructure to do it? Since it's a self-assessment, we also tried to do some audits of the collections to see whether what people say that they have in their collections and how they manage their collection is actually what we think they should be doing. So basically, this analysis is still ongoing, and Anne van Balen from KU Leuven is leading this exercise. Once this assessment is done, we will have a look and see where the priorities are in the coming years on making at least the physical curation of our collections better. Where are we in the timeline? Disco Flanders runs currently from 2021 to end of 2024. We are more or less a little bit over half of that period. And we did our first inventory. We saw it, I have the numbers. We also started already the assessment of the state of the collections. We have a first round. We just need to do the data analysis still. And in the last year of our project, we will repeat the inventory exercise. Empower people. People have different skills. They're not always all at the same place. So basically, some collections might have people that are stronger in one particular topic, and other collections might have people that are experts in boxing. I don't know. But we really need to empower people and make sure that we transfer this knowledge from one person to another, or that we collaborate and that we can visit each other, make sure that we get that knowledge transferred from one person to another. And one nice example that we have here is from Emily from the Research Institute for Nature and Forest, who actually saw that within our collections, we all have DNA samples. We all have DNA collections, but none of us knows what to do with it. They are all stored in fridges, and okay, in the best case, we are tracking those, but there is really a need for our collections to do this better. So basically, on initiative from the collections themselves, we started a working group on managing and optimizing DNA collection management. And this group did already a lot of work and actually made a lot of progress to streamline the way we deal with DNA collections within Flanders. Another set of people that we often forget is the public, because we are there for the public. We also need the public and volunteers within our collections. For an example, at Messe Botanic Garden, we have about 180 employees, but we also have over 300 volunteers working in our collections, within the living collections and in the preserved collections. So it's really essential for us that we also manage our volunteers correctly. And this is not a passive thing. It's not our volunteers are coming, they are doing some work in our collections, or they're databasing our specimens or whatever, and that's fine for us, it's for free, yay. No, we really have to have people managing our volunteers, making sure that they are happy, that they keep on doing what they're doing, and that they find some reward in what they're doing. So basically, this is a full-time job for someone, really looking at volunteers within collections. Engaging with the public also increases our visibility. If we want to stay relevant as a collection to society, we really need to make sure that we engage with the public, and we do that in many different ways. For example, last year or 2 years ago, at least, we organized the BioBlitz, where the garden was open for 48 hours and everyone was recording biodiversity in the garden. It's good to get attention to biodiversity, but it's also a nice event. People get to know your collections and so on. Then invest in infrastructure. If we want to manage our collection, and okay, there is already one shown, but that doesn't mean anything. That's just a mistake in the slide. If we want to manage our collections correctly, we also need good infrastructure. We cannot keep running our collections on software which is dating from 25 years ago. We need to be up to date with what we're doing. So we started within the Scaflanders a whole landscape analysis and requirement analysis of what we need in our collections. And now our public tendering just is really in the process of selecting a new collection management system for the Disco Flanders Consortium. And if you want to know more, but at the moment we can't say much more, please contact Wesley. And to give an idea on how difficult this is, the landscape is vast. So basically, we had a big exercise going on getting the best system for our case. Invest in data and new technologies. So basically, we also have people within our collections that are busy dealing with data standards. We have people thinking about image infrastructure. We digitized the whole of our herbarium for almost 3.5 million images. What are we doing with them? How are we dealing with them within Disco? So we really have to think about this in the future. And then how do we get more information from our specimens? And we had already a couple of presentations this week about AI and using segmentation and getting information out of the specimens. We really have to do that and develop this further to make our collections more relevant. And we have to invest in collaboration. We are not alone. There are other research infrastructures around. And if you look, I like this figure. It's stolen from the Disco at European level. Disco is very specific because it's dealing about digital data of specimens. None of the others are doing this, but if you look at in a taxonomic and spatial scale, we have a huge overlap with all the other infrastructures. We really need to talk about this. And we need to talk about this on a global level, a European level, but also at the local level. And in our case, that means that we have to talk to the people of LifeWatch in Belgium that are doing biodiversity monitoring. We have to talk to the people from the digital humanities, because those are the people that are dealing with the same kind of data. And how do I do that? Focus on your strengths. And one of our strengths is our crowdsourcing platform. We build up within our consortium a huge expertise on using crowdsourcing to enrich our specimens. And that's where we have to invest in, because that is what we are good at. And we have already a few examples. For example, we did already a lot of digitization for the Museum of Cycle Racing, but also for expeditions on a ship to get specimens out on monitoring and so on. And with that, I want to thank all my collaborators. I tried to list a couple of them, but there are way more, and the project is evolving so fast that it's hard to keep up. Thank you very much.
All right. All right, here we go. We're almost to the end of the Thursday, but not quite. So good afternoon. My name is David Bloom. I'm here to announce the start of a new digitization project focused on mammal traits and extending mammal records called Ranges. We'll start at the beginning. Once upon a time, there were efforts to digitize and publish mammal data from various natural history collections. These efforts, including the Manus Project of 2001, stimulated a significant increase in the community's participation in data sharing and capacity building. They supported the growth of the nascent Global Biodiversity Information Facility and provided a foundation for future projects such as VertNet and IDIGBio. Despite the success of these early digitization efforts, the amount of data digitized was limited by the capabilities of these database applications of the time and available grant resources. Today, 22 years later, most institutions still lack the resources needed to digitize much more than the data available on specimen labels. As a result, trait data from millions of mammal specimens remain undigitized, partially or fully digitized but unmobilized, or mobilized but in non-standard formats. I mean, have you guys looked at your occurrence remarks or dynamic property fields recently? I mean, that's kind of how it goes. It is the fragmentary nature of these data that inhibits their discoverability and use at a time when they are needed most to set baselines and address questions about global change. That's why we've created the Ranges Project. Ranges, based at the University of North Carolina at Greensboro with PI Brian McLean, will provision individual trait measurements from nearly 1.2 million curated mammal specimens to help us to address some of the key evolutionary and ecological questions of our time. The primary goals for Ranges are pretty simple. First, we will digitize the traits that describe those 1.2 million mammal specimens from Western North America, including the US, Canada, and Mexico. Append those new data to existing digital records and publish them in open standardized formats. Secondly, we will digitize and mobilize 4 regionally significant mammal collections so that those data will be accessible and discoverable for the first time. And third, we will develop a new distributed collection of dense, intraspecific level 3D images for more than 3,500 specimens using microcomputed tomography and other imaging tools. The focus of this project, at least in this iteration of the concept, is terrestrial mammals from Western Canada, the US, and all of Mexico. We will apply FAIR data standards across all of our project deliverables and products. We do this with the goal to make several areas of scientific inquiry and exploration easier and more effective for the practitioners in the field and the students in the lab. We are particularly interested in 5 areas of study and the synergies that Ranges can provide with other funded projects. In the first of these synergies, Ranges will improve the ability to link specimen-level life history traits with environmental variables. For herbivorous mammals, for example, Ranges will synergize with plant-themed digitization networks whose products support the reconstruction of past ecological contexts and food availability, such as the California phenology and the Southern Rockies TCNs. Similarly, Ranges can provide trait data for insectivorous mammals, such as bats, which will provide synergies with networks such as the Southwest Collection of Arthropods and the Lepidopteras of North America. Ranges will complement efforts to expand access to specimen-level paleontological resources, most of which exist in repositories that tend to emphasize spatial distributions. Ranges data will support efforts to expand access to data that place fossils into detailed paleo-environmental context to establish data resources for quantitative analyses of trait evolution and functional trait turnover. The traits mobilized by Ranges will also support research into host-parasite interactions to synergize with projects such as the Terrestrial Parasite Tracker. Ranges data featuring host morphologies and life histories can be linked to parasite associations and infection intensity, and we expect to uncover opportunities for novel science to occur between host data and parasite images and other derived specimen data. Data mobilized through ranges will aid monitoring efforts in the Arctic by documenting shifting trait values as they modulate species, persistence, and community interactions. More than 10% of the specimens included in ranges are from Alaska and northwestern Canada, including some historically significant holdings that represent repeated sampling from remote sites. Finally, traits are the basis of our understanding of species-environment interactions, and we expect the data mobilized by ranges to help groups such as the National Ecological Observatory Network to establish new baselines for future prediction and next-generation models that incorporate adaptive and plastic phenotypic responses. Now that we got our annual quota of synergies out of the way, I can take a few moments to share with you some of the details. The Ranges project, like any blushing bride, stands in front of the generations that came before it. In this case, the foundation is the group of 19 institutional partners plus the University of Oregon. For some of these folks, the digitization game is an old one, but for others, this will be their first rodeo, and we promise to capture all of their thrills and spills on our forthcoming TikTok account. There will be new things, like the approximately 5 million new traits we will digitize over the next several years that include some familiar favorites, such as hind foot length, tail length, testes size, and body mass, as well as possible traits discovered and described with the help of CT imaging. We'll also take some expeditions into field notes with notes from nature. And not to make all of you jealous, but we are working with the Futures Project, which is run by a secret sect of trait-thirsty paleo-archeo-neo-focused pirates eager to aggregate trait data and drink White Russians. This smarmy crew will be certain that the traits captured by ranges will align with and possibly expand the Futures traits ontology, and maybe, if we are all really good to each other, we'll be able to improve and expand the traits vocabularies and extensions for use with Darwin Core. Of course, we don't want to reinvent anything that is already available to us for use. I mean, reinventing never happens in this community, and we don't want to be the first. So we'll use some well-worn tools and workflows. We'll use the trader extraction tool developed by VertNet and the Gorelnik lab at the University of Florida to identify and extract traits from existing records. And we'll use the VertNet migration toolkit to process all of the data for quality, completeness, and standardization to the Darwin Core. In the end, all of the data will go to VertNet, iDigBio, and GBIF, and the traits will also be provided to the Geome project and be placed on the shelf of honor within the Futures portal. Finally, a little something new. Ranges will award a series of mini awards to a few select individuals in need of 3D imaging of specimens of relevance to the Ranges project. You do not have to be a project partner to qualify, but you will have to apply and make your case to the Ranges PIs and advisory group. Although we have yet to develop the application process, you should be prepared to provide your application in both a written format as well as an oral presentation in the form of a stage production, musical performance, or some form of avant-garde performance art. Ranges is very new, just started at the beginning of this month, so we're still in the process of ramping up the project. Our Slack space is up, but the website and other accounts, including our GitHub, will become available in the coming months. Should you want to follow the project, follow our progress, or simply provide us with digitization memes, you can contact any of the project team directly or join our Slack. Thank you for your attention. Yeah, I don't like to say more than I have to say. So if anybody has questions for me or anybody who's come before, we got 5 minutes. You can go pee. Nobody will miss you. It's all right. We haven't decided that just yet, but if I may scoot backwards just a little bit here, the list, I realize it may be well, you can read that from where you are. Those are likely those expeditions will come from one or more of those institutions, but we have yet to determine who is most who might be most effectively used in that particular context. Those 4 institutions that you see up there that have mostly slashes or dashes across there, those are the 4 that haven't been digitized at all. So they're probably good candidates. I imagine they have field notes and other things that need to be exposed to the light of day. But we have yet to make that determination. If anybody wants to be a smarmy, trait-thirsty futures person, you can talk to me at some point too. That's a fun group of folks. Other questions? Excellent.
All right, in the interest of staying on time, we're going to stay on time. So we have like 4 minutes until our next speaker. All right, so talk amongst yourselves.
All right, I think we'll go ahead and start. My name is Vincent Dotto Beltran, and I'm a conservation scientist at the Getty Conservation Institute. I'll be presenting today with Adam Foster, who's an archivist from the Academy Film Archive. I also wanted to acknowledge my other co-authors, Jennifer McGow and Ellen Perlstein from the UCLA Getty Interdepartmental Program of Conservation of Cultural Heritage, and our consultant, Kirsten Opstead. The work we'll discuss today is a bit of an outlier among the suite of digitization talks, but we do touch upon the common theme of virtual accessibility, particularly with respect to color. Bird specimens can be a vulnerable part of a collection. Some are extinct or critically endangered and are thus irreplaceable. Some of these specimens exist on semi-permanent display in dioramas or are part of study collections, and their feather colorants, many of which are sensitive to light exposure, can exhibit significant color change over time. The seed for this work emerged from a project at the American Museum of Natural History, which examined the impacts of cleaning, pesticides, and color restoration of feathers. And two of our paper's authors, myself and Ellen Perlstein, participated in the development of this project. And I should also plug that Julia Sobalski from AMNH is going to be speaking more about this project this afternoon at 4 p.m. in the Imperial Room. In the middle image, you see feathers that have been artificially aged, and at right, their efforts to physically recolor them, which are quite successful. But the process of physically recoloring feathers can be challenging in terms of the precision of color, reversibility, and how well and how safely the colorant adheres to the feather. For some object types, such as indigenous feathered regalia, physical recoloring may pose ethical concerns. So our team sought to explore virtual recoloring as a complement to the AMNH project. The concept of virtual recoloring has precedent in the museum world, most famously with the Harvard Rothko murals. These objects were displayed in a brightly lit room for years and severely faded, as shown in the bottom left. As part of an exhibition, conservation scientists at the Strauss Center virtually recolored these murals using digital projection, the results of which can be seen at right. What was particularly interesting was that the digital color projections were turned off at 4 p.m. each day. And this sparked people gathering together and having discussions whether or not they liked the recoloration or they thought it was terrible. But in the end, it was still a discussion that engaged the visitors to the exhibition. Another example of virtual recoloring was work done by Vino et al. In 2011 to use multiple LEDs to recolor a bird specimen. At left, we see a pristine Madagascar fody, and at right is the faded object recolored with various 3 LED combinations. While published as proof of concept, this illumination approach for bird specimens has yet to be employed in a museum gallery. Since the late 2000s, LED technology has rapidly developed. Full color tunable LEDs employ 3 or more LEDs inside a single lamp, and combinations of these allow for flexibility in output. For our study, we employed commercially available tunable LEDs by Ketra, and these contain 4 LEDs, red, green, blue, and white. And their software interface shown at left allows one to change color, temperature, or hue. This flexibility allows you to adjust the spectral power distribution, or SPD, of the lamp. And these SPD graphs show intensity on the y-axis and wavelength on the x-axis. The SPD can be described as the fingerprint of a lamp and is typically fixed. However, in the case of tunable LEDs, a single lamp can go from a 3000K white light, shown here at left, to a red light shown on the right. In the same way one adjusts color, you can also attune the white light. On the left, we again see a 3000K white light with 0% vibrancy, which means that the white light is produced almost entirely by a white LED. On the right, we've increased the vibrancy to 100% while maintaining a 3000K color temperature. The white light here is produced by a combination of red, green, and blue LEDs. And we'll see the effects of this in a bit when Adam comes up. So Ketra tunable LEDs have been used by several museums. The Art Institute of Chicago has used Ketra lamps to optimize the visual experience of polychromy sculpture, while the Los Angeles County Museum of Art can use Ketra lamps to meet an artist's request that interior light match the changing qualities of exterior light. So we'll shift now to our experimental setup. And what we did was position a tripod in front of the bird specimens, and these bird specimens were generously loaned to us by the Natural History Museum of LA County. And we had 4 Ketra tunable LEDs that were directed toward the specimen, 2 from the tripod and 2 from the table, and you can see them circled in green on the right. Additionally, we added a 5th Ketra LED directed towards the overflow of light behind the bird in order to counteract that color. And then the shape of the Ketra light beams were refined using cinefoil snoot. So we attached the cinefoil to the end and were able to shape it to hit the area that we're interested in. And finally, we added a fixed frameable 3000K lamp in order to spotlight specific features on the specimen during the recoloring process that we did not want to change, and that's shown here in orange. So now we'll move on to the results.
Thank you, Vincent. So yeah, first we'd like to share results of this faded cardinal. This cardinal was loaned to us by the Los Angeles County Natural History Museum. And compared to the reference we see here of a living cardinal, we can see that our mount that we're using is significantly faded. Oh yeah, let me get the laser out here. So here's the mount that is being loaned to us. And so this mount is being lit at a color temperature of 3000 Kelvin with the vibrancy set to 0. And this is forming our base setup where we can now demonstrate ways that these tunable LEDs can interact with displayed objects. And so first, we'll show what it looks like when we keep the color temperature the same, but we change the vibrancy from this 0% to now 100%. So already we can see a noticeable change. It might not match our reference down here of a fully recolored cardinal, but we can see the red popping out a bit more. We can also notice kind of sharper whites and oranges, and can tell that the shadows are a bit more defined as well. And then to remind ourselves what's going on in the spectral graphs in the lamps. So when the vibrancy is set to 0, it's using mostly that white LED within the lamp to create the color temperature of the white light. Whereas at 100% vibrancy, we're only using the red, green, and blue LEDs to mix together the white color. So looking past vibrancy, next we'll show our attempt to tune the lights to cast specific colors onto this mount in order to compensate for the colors that have faded. So that's this image here on the far right. And so what we have done now is we've tuned the lights to throw a specific red light onto the head and the back, as well as on lights below shining up a reddish orange onto the breast, and simultaneously casting an additional white light directly onto the beak, pinpointed onto the beak, and across the branch here. And this was important to maintain areas of separation after introducing our recolored light. And you can see here how it is not as simple as just throwing a colored light onto a faded object. We wanted to put red on this bird, but if you don't take into the account the other nuances that are existent in the scene, specifically the branch or the beak, and it could change from bird to bird. In this case, it would just look like you're in a red room with a bird inside of it as well. And what excites us most about this setup is witnessing the transition in real time. So what we have here in this image right here is a video capturing the live transition between the two light settings. So this allows the bird to be displayed both faded and recolored. And it's fun to think how the public can interact with this display, perhaps like addressing how and why objects fade, as well as demonstrating a process of restoration. We also recorded the lux values for the recolored scene. So if you're thinking about budgeting a display time, the red light we were clocking under 50 lux, but across the branch and onto the beak, it was peaking, and that is because we have that additional white light being cast in those spaces to kind of get rid of any red that was spilling into spots we didn't want. And that just demonstrates where that extra white light is. We've also been working with this female bluebird, and for reference, we also want to show the difference in coloration between a female and male bluebird. It's just quite different. And that way, when looking at our tests here, performing the same tests as we did with the cardinal, we can note a slight pop in color when we just work with the vibrancy tool. And this could be a good tool, the vibrancy, for specimens that aren't as severely faded. If you just need to get some of those colors to pop back in. And then when looking at targeting blue light onto this blue bird, we saw the potential for designing a scene that could recolor the bird as a male or a female bird. So right now the blue is targeted on the tail, but if we also set up a scene where that blue stretched across the back and onto the head, we could toggle back and forth, and this could be useful for anywhere or any places that only have one of these specimens in their collection. And so looking forward, we have a few more birds that we want to test this virtually coloring with, as well as working with feathered regalia, assessing the cultural needs, as well as just considering the complexity and the textures and the colors in this work. We also want to look into a more mathematical approach, predicting color compensation using spectral analysis. And finally, implementing design in a gallery setting so we can allow the public to interact with this kind of exhibit. And we'd like to thank AMNH for their continued inspiration in this work, as well as the Los Angeles County Natural History Museum, who's been loaning the birds that we've been working with. Thank you all for joining us. And if you have any questions, I believe we have some time left.
Have you used projectors to get pinpoint the exact, like we've got a projector here and it's got like a bit of area, set areas in set colors. Have you tried using those?
We have not been doing projection mapping, and that's very similar to what the Rothko restorations were. This is literally the same thing as these light lamps up here, smaller than maybe the ones up here, but we are targeting light bulbs into specific areas and mapping in that way. So it's not a digital kind of recreation of that scene. I don't know if you want to.
Yeah, I mean, I think that would be ideal if you could use a pixel by pixel recreation. Only problem is our samples are very different from bird to bird, and it just becomes a little bit problematic in order to do it at that detail. But how we've tried to shape it is by having these centifoil sheets on the end of the lamp that try to give us some control as to where we're pointing that light. So we're doing it in a gross manner, but it is possible to use pixel by pixel recreation. I think if you had a more complicated bird with a lot of different colors and it was the only bird that you were going to light, you could attempt to do it. But the other complication is it's a three-dimensional bird. So how many projectors are you going to need? You know, with the Rothkos, it was flat.
So I'm curious to know, how long did it take to get to do one of these? Is it something that's very scalable across lots of specimens, or is it really quite a protracted effort for an individual specimen?
Yeah, I mean, as you can imagine, I mean, none of us were lighting designers. So our consultant was extremely helpful in just kind of getting us up to speed on how to do this. So our initial efforts took forever. It just took a while for us to understand how many points of light we wanted. But then once we got kind of the hang of, you know, what we were doing, how many points of light did you want to try to employ? And then it became easier, but it still takes some time to really hone in what you want to highlight in terms of the color. Is it the color you want? It was super helpful to meet with the people from NHM-LAC just to get a sense of, were we doing the correct thing? In fact, on the bluebird, we just assumed it was a male and it was faded. So we were shining it completely different than what it actually was. And, you know, that kind of sparked that interesting discussion about, you know, that this could be a curatorial tool to look at gender. But, you know, it's not difficult once you get the hang of it. I think for us, the really interesting thing is how's this applied in a gallery setting? And that's kind of the next frontier. I know NHM-LAC is interested in trying to employ it into a small gallery or like a small display. But, you know, if you were trying to employ this into a diorama, it becomes trickier because you're dealing with a much bigger space. And, you know, are you going to highlight one bird in that entire diorama?
Thanks.
All right, so this concludes this session. And again, thanks to our diamond sponsors. There's nothing else happening in this room that I know of. So if you want to hang out and talk to the speakers a little more, I think that's okay. But the session itself is done. All right, thanks.